Hello, hello, hello. Is there anybody in there? Just not if you can hear me. Is there anyone at all? Relax, relax, relax. How's that? How's that for an intro? An intro that is a song that starts with hello and is relaxed. Anyone scared by this one? And hopefully you can actually hear me and I'm not just talking to myself. Well, that certainly looks like someone can hear me. Well, I see a lot of highs. Okay, can hear. Great. I got a confirmation. That's the main thing I was after. Amazing. And hopefully no one got scared this time. Surprised? Yes, maybe. I am just talking to myself. It's true. Like in one philosophical sense, that is what's happening. Amazing. Let's then also see if I do this, if you can see my face. You should see my face full screen. Sound okay, no video. Yeah, I know that's intentional. But in theory, now there should be video, right? You should see my beautifully arranged lighted face. Yes. Okay, sweet. Okay. Video check. And then if I do this, you should now see my screen. Yes. With the Avro IDL specification. And just to see that, because we've seen this in the past, that the colors suddenly looked really weird. So just to test that the colors look normal, like whites and blues also look okay. I did somewhat bravely do a full system update this morning, like 30 minutes ago. So that's why I want to make sure to check that like OBS hasn't randomly broken its encoding or something again. Oh, the keyboard clicking before the song made it not scary. Oh, interesting. So maybe I should type and then sing. That sounds like not a bad start. Okay, then I think we're in a pretty good place. We're almost ready to start. Let me rearrange my desk a little bit here. This goes over here. This goes over here. I guess before we start, we can do a sort of a survey of the room. How many of you know what protobuf is? So not Avro, but how many of you know what protobuf is? Like raise a hand or something, I guess. Or react or something. Sure, crab with raised claws seems fine too. Okay, so kind of. We have like a decent number of yeses to protobuf. How many of you have used protobuf? So not just know what it is, but have like actively used it. You've written a proto file, like you've actually dealt with it. Let's do thumbs up for this one so that it's distinct from the previous one. Okay, fewer. Thumbs down. Sure, that's useful too. Okay, so there are fewer people who've used it. And then now comes the question of how many of you had heard of Avro before I wrote about it. So if you went and looked at the documentation after I said I would do a stream about it, it doesn't count. How many of you like have heard of Avro before this? Let's do, I don't know, what emoji do we want to use for this? Open mouth emoji. Sure, why not? Because the chat just sort of melds all of them together, right? Okay, so not zero, but there's a pretty clear linear trend here of fewer people have used protobuf than know about it, and fewer people have used Avro than have used protobuf. Although, like, more than I would have thought. Okay, cool. All right. So I think it's time we get into it. I'll also explain more in depth what it is during the stream itself. So I think we should just get started. Okay. All right, here we go. Hi, folks. Welcome back to another impl Rust stream where we take ideas and we build Rust code out of them, I guess, is the whole premise, which it feels like most of programming in Rust, but I guess we do it on stream, so hence it needs to have a name. So in this stream, we're going to take a tool for the Avro ecosystem, and I'll explain what Avro is in a second, that already exists, is written in Java, and I just want a version that's not written in Java. And there's really like one main motivation for it, which is the existing Java tool, while it is maintained by the official maintainers of Avro, it does not do a great job of giving good error messages. And as you'll see when I explain what Avro is, bad error messages in this case can be extremely time consuming to debug. And so I wanted to make that better. And you probably can make this better in Java, but I don't know Java very well. Not to mention, I can think of like another couple of things that I would like to be different. And so I'm just going to try to port it. And I'm also going to use a decent amount of LLMs for this one, which some people have like raised question marks about. And the reason actually is because this specific kind of task is the kind of thing that I found LLMs to be really good at. Like I've mentioned in the past how, I have a lot of skepticism around LLMs, but the skepticism is, I think is become more refined maybe over time, that I've sort of recognized that there are some things that agentic coding in particular do really well at. There are many things it's terrible at, and there are some things where it's good with enough guidance at, and there are some things it's really good at. And this is actually something where I think it is really good at this kind of thing. In particular, the work we're about to do has two properties that I think make sort of set up the agentic LLM for success. The first of them is that there's an existing open source implementation in a different language that we just want to port, right? So the existing code already exists and we just want it in a different language. I've found LLMs to be very, very good at that kind of translating from one language to another when you have the other as a reference. Especially I've used this a lot going from Bash to Python, for example, as Bash scripts try to grow too large and unwieldy, turning them to Python or potentially turning them to Rust. It does really well for that. And then the other, and this is another critical component to it, is we have a reference implementation where we can basically generate an infinite number of examples of correct behavior, right? So, and this gets back to what Avro is, but the tool we're building is basically a sort of file format converter that takes it takes one file format and turns it into a different file format. They're both text-based, and so if we have a given input file, we can tell the LLM, well, if you want to check whether your implementation is correct, then pass it through the official tool, pass it through yourself, and check that the outputs are exactly identical. And that kind of setup means that you can kind of leave it to run on its own to figure out its own problems until it arrives at a solution that like fits the pattern exactly. And this becomes more like it's almost like a semi-random walk. It's almost like fuzzing to get the right solution. But because you have a good reference, it becomes more like you can almost do property-based testing over this thing. So let's get into what Avro is. So Avro is, for those of you who've heard of protobuf, Avro is fairly similar. So Avro is a system, mechanism, concept, combination of the three, spec, combination of the four maybe, that lets you describe interfaces for both for data exchange and for remote procedure calls like APIs in a particular format, a standardized format, and then you can generate servers and clients based on those definitions of data types and potentially those definitions of service endpoints. And you can generate those in multiple different languages. So for example, you could write a schema that defines, here are my various data types, and also here are the API endpoints that I want. And you could auto generate a client in Rust and a server in Java, for example. And then you obviously have to fill in the sort of business logic, but it can generate the interface for you. It generates the serialization and deserialization protocol between the two, and brings you a bunch of tooling to work with that as well. protobuf obviously is the one I think most people know about from Google. So this is Google protocol buffers. And there are a couple of differences between Avro and protocol buffers. For me, two of the ones that are most relevant, and the reason why I ended up working with Avro in this particular setting that I'm using it in, is Avro has support for these things they're called open containers, which are basically, this is not to be confused with OCI images and the like, but they have a mechanism to say this is like a byte stream that accompanies the data that's exchanged. Protobuf doesn't really have anything equivalent where you can say this. gRPC does, but I don't want to use the RPC part. I just want to use the data interface definition language. And so Avro has this mechanism for saying, here's like the data type that you're going to send or receive, like is the definition of a message. And this part of the message is just a byte stream where we might not know the length in advance. The other thing Avro has is this notion of logical types. So it's not like your schema has to be constructed just of objects that have fields, where the fields have types that are either themselves objects or they are primitives like booleans, integers, floats, etc. In Avro, you can also define your own logical types to say this is an integer, but it also has to follow the following rules. Like, for example, it's an integer, but its range is between x and y, or it's a string that has to match the following set of patterns. And you can kind of hack together something similar in protobuf as well, but it becomes much more ad hoc. Like in Avro, this kind of logical typing is directly supported by the spec itself. It sort of has a place where it goes. So why do we need a tool for this? Well, so Avro itself is a pretty vibrant ecosystem. It's maintained by Apache, or rather it's an Apache project. So it has a bunch of maintainers, a bunch of users. There's an Avro project on GitHub that's pretty active. And it's all of the tooling there is written in Java. It can still generate code in lots of different languages, but the implementation of like the parser and the code generator and all of that stuff is in Java. And that's fine as far as I'm concerned. It's like, I don't necessarily want to have to install all the Java stack to run these things, but so be it, it's fine. But there is one particular tool that is kind of unique to Avro that doesn't exist in the Google protocol buffers ecosystem, which is that Avro doesn't just have one file format for describing interfaces, describing data types. It actually has, well, let's say two. So it has one that is called the IDL. The IDL is an interface description language, and it looks very much like protobuf. So if you look at the IDL language, there's sort of an example at the bottom here. So here, for example, schema.avdl. So you declare a namespace. Okay, fine. You declare this is optional. You declare an enum type. You declare some other type. You declare a record, which is sort of a equivalent to message in protocol buffers. You give a name to that record, and then you say it has the following fields of the following types. And then you can include additional attributes for those fields as well. You have unions, you have default values, and so on. You have arrays, so you can say this is a list of things of the following type. So this is an interface description language. This is great for humans, right? So humans can read and write here. You have comments, like you have all the niceties of being able to like nest and like write the code and format the code however you wish. And it's fairly easy to read. Even if the file gets large, you can sort of logically separate it into multiple files and whatever organization you want to do. It's okay for machines, but it's kind of annoying to parse something like this, right? Because it has its own grammar, it has its own syntax. And so for that reason, Avro also has a separate schema type, or file type really, which is a JSON file type that is basically a JSON encoding of the information that is in this file. So if we go over to the actual specification for Avro, you'll see that it says a schema is represented in JSON by one of these where it has type and things and attributes. And if we go down, they probably have examples near the bottom here too. This is what a schema looks like in in the Avro JSON based format. And so this can express the same kinds of types, but it does so in a way that's much easier for machines to parse, process, do code generation based on, and so on. But you need something that converts from the IDL to this kind of JSON representation, right? So if you have this, but all of the tooling expects to be given this, then how do you go from this to that? Well, there's a tool that ships in so there's an Avro Tools Java package that includes a bunch of various kind of Avro tools. And one of the ones that it includes is this IDL tool, where you give it an AVDL file. That's the IDL we just looked at here, the human writable one. And it generates you an AVPR or an AVSC, which are the JSON representations. The difference between AVPR and AVSC here is that AVPR is a protocol. So think gRPC, like it's a mechanism for describing service endpoints as well. Whereas AVSC is just the data types and not the service endpoints. And so when you run this tool, it will take this human readable thing and produce a JSON readable thing. And you can use it for schemas and protocols and whichever you prefer. And this tool itself seems to be maybe less well maintained than the other tools. It's not that it doesn't work or that it's broken or anything like that. It's just that it seems to have not gotten as much, care, love, and attention. And I think maybe I've been spoiled by Rust here, but when you run this tool, if you have an error in your IDL, you don't get very good error messages. So you will often just say, this file just failed to compile or failed to be translated into JSON format, and then not tell you why. And this can be really frustrating. So imagine you have like 1,000-line IDL file and you misplaced a comma. It won't tell you where you did so. And so you need to either just look really carefully, or it turns out there are also people who've built IDE integrations for this, an LSP, among other things. And that one actually has a better parser that gives you good errors. So you open it in your editor, you look for where the editor tells you the problem is, and then you go back and run the tool. And that just feels kind of silly. Not to mention, you also need to have Java installed, and you need to have this jar in order to run the tool. And that makes me a little sad, but who am I to say? Part of this is also, I don't use Java very much, so I don't usually have Java installed on my computers. I will install it when I need to. It also means I need to futz around with Maven in order to be able to grab the jar, or you can also go to the download page and then they have a mirror where you can look through basically an FTP server where there's a bunch of jars you can click to download, which I don't love the idea of. And so I thought, well, can we just write just this tool? I don't want to port all of Avro tools. I just want the converter from the IDL format to the JSON format in Rust so that I can just run it in a Rust native project. So that's what we are aiming for. Is it clear what this is for, what we're doing? I'll demo the tool in a second, just because, so we can show that it actually does what I said it does. Okay. People seem to think it's clear. Great. So then what we'll do is we'll do cargo new, and we'll call it AVDL, which is the file extension type for the Avro IDL. We could come up with a clever name here, but I don't think we need a clever name. And then what I will actually do is I will create a Git submodule that brings in Avro. The reason for this is just because we kind of want to reuse a lot of the riddle is good. Riddle is good. Yeah, but then it doesn't have the A. Because there are lots of IDLs, not just Avro. I don't hate riddle, though. Oh, fine. Fine. Riddle. Riddle? Radval. No, I'll just keep AVDL. Let's not go down this rabbit hole. A riddle. So now it's a riddle. Oh, a riddle. No, we're just going to stick with AVDL. Let's not make it complicated. So the reason I want the Avro checkout in here is because one of the things we want to do is make use of all the test cases for the existing code base. So if I cd into Avro here and I search for AVDL files, you'll see that in the Avro repo, there are a bunch of AVDL files that are used as tests for the Avro tool that they have. And we would, at the very least, expect that our tool produces the exact same output as the upstream tool when run on these files. So we basically want to duplicate their test suite and make sure that we also pass the exact same test suite. You'll see there are a couple of other AVDL files here that are also like test files for the compiler and stuff, and we can just run on all of them, right? Because we have the reference implementation. Our goal is to produce the same thing as the Avro tool jar does. And in fact, let's look at what that looks like. So first we'll grab, that's not the right command. That's not the right command either, because it is, it's like you need -d get dependencies equals false. No. I did this earlier. Yeah, it's this. No. This. Can you tell that I don't use Maven very much? What? No. I was sure I had that. Fine, we'll do the other one. So you can also download the jar directly from Apache. So let's do that instead. I don't want to fetch all of these dependencies from Maven. That seems annoying. Anyway, we now have the jar. Hooray. And so now we can run, in fact, if you go back here, you'll see there's a usage example. So we can take this exact usage example. And we will run our Java tool. This is going to be in /avro/idl/ what? Oh, I'm already in Avro. So it is going to be, where was it? Lang. Okay. So it's in Lang Java IDL source test this. And then we'll call it, we'll set the output file to be namespaces.avpr. It ran, and now we open namespaces.avpr. Oh, that's annoying. Fine, I can fix that. I'll fix that right away. Config editor. No, neovim init. Yes. Okay, it's very insistent that I fix this right away. Yes. I don't want you to bother me every single time I... Cool. The URL it told me to use instead does not work. There we go. Okay, great. Stop bothering me. Cool. So when we look at the AVPR file that it generated, you see, in fact, let's look at the input file first. You see this is an AVDL file. It has a protocol defined in here. So protocol is like a service, like APIs and stuff. And you'll see it has a bunch of, it has types and records. And then if we look at the generated file, we should see the same types, like the fixed here, fixed in other namespace and so on. And the same records and the nested fields and everything. And it's just in JSON format instead. So the tool works. Now let's see what happens if I try to change this and I do, I don't know, remove this semicolon. If I now run this. Okay, this one's not too bad actually. So exception in schema parse exception, line 37, mismatched input, record and other name, expecting semicolon or colon. What happens if I put a comma here? Great. Okay, so I put a comma instead of a semicolon. Exception in thread main, schema parse exception, no such element exception when parsing, with no indication of which line the problem is on or anything. And I mean, granted, parser errors are difficult, right? Because this might be a completely valid syntax, like the grammar is accurate in the file that I wrote, but when we parse it, we end up with the like inability to parse what was produced. So like there's some amount of leniency here, but I would like to see this error be better. And so that is going to be the primary difference between the Java version of the tool and ours. Hopefully, we will find out. So let's return that to a semicolon so the file remains valid. And what else do I want to show here? There's one more thing to be aware of. So the Avro Tools jar also has IDL to schema. No, what's it called? So there's actually two commands. If I can find the other one. Yeah, so there's IDL to schemata, which is different from the IDL tool. And it's not entirely clear how, because these two tools are both invoked through the Avro Tools package. This one says tool implementation for generating Avro JSON schemata from IDL format file. This one says extract the Avro JSON schemata of the types of a protocol defined through an IDL format file. The actual difference is that this one, if you pass it a protocol file, so one that defines like API endpoints and stuff, it will parse the thing, extract just the type definitions, but not the endpoints, and turn it into a schema file instead. So in other words, this one will produce an AVSE or an AVPR, like it will produce everything that's in the input file. This one will not include the protocol bits, is at least my memory of this. Yeah, I'm pretty sure that's the difference between them. I don't end up using this one very much. Okay, so now let's figure out how we start doing this. And the way we're going to start doing this is we're going to kick off Claude and see what we can get to. Yes, I trust this folder. That's fine. We'll enter plan mode. And then what we're going to tell it is, I think this is like, it should be fairly easy to get it started here. And then we're going to have to vet a lot of what it does, because I suspect it will get quite confused. So what we're going to say is I'm trying to port, and then we're going to give the path to the tool, which is going to be this one. Oh, I want to copy this path. GitHub, thank you very much. I'm trying to port to Rust. I would like to reuse. Oh, this is another important part. So one of the reasons why I think this is actually feasible is because the grammar for the IDL files is defined using something called antler. So antler, or another tool for language recognition, is a tool for writing parsers. So you basically, if we open up the file for it here, it's a domain-specific language, DSL, that lets you write out the grammar for some language you want to parse. And once you have that grammar, you can pass it to Antler, and it will generate you a parser for that grammar in whatever language you choose. So, for example, you can, and this is what Avro does, you can use Antler to generate Java code for the Antler grammar. And now we have a Java program that can parse that file. But you can also use it to generate Rust code. And so we can take the grammar and just use that to generate a Rust parser right off the bat. And in fact, this part we don't, wait to start Claude here. Oh, you're right. I'm in Avro. I don't need to be. So let's first get Antler to generate us the Rust code that we want, and then we can build on top of this. I think I already have Antler. Yes, I do. And then let's see if the Antler I have builds with Rust already, or whether I need to custom build it. So what I want to do is this and see what happens. Antler cannot generate. Okay, so the Antler for Rust thing is, yeah, okay. It's going on in this repository. This is the main repository. This README, I think, is out of date. But I think this is not considered, like, it's not upstreamed yet, or it's not enabled as a default distribution of Antler, the Rust implementation. So we need to figure out how to get this one, which I think is just going to be a matter of us. Oh, I see. No, it is still in a fork. Great. So what we're going to do. Yeah, the rabbit hole begins. It's true. What we're actually going to do is we're going to cd. Do I want to do this under us? Yeah, sure. We'll go get submodule, add this one. Rust. Such large projects to clone. Come now. All right. So how do we build this thing? README builds. How to build. Doc building Antler. Most programmers do not need the information on this page. Cool. Well, that's not us, sadly. Okay, we have the source, yes. Check your environment. I have Java, I have Maven. The current Maven build seems complicated to me. Great. Okay. Don't forget this on Linux. Okay. So this is going to be do I want it to install? Can I tell it to building. Install sounds a lot like not just build, but okay. Fine. So we're gonna run we're gonna run something like this. Let's just see how that goes. Yep, it's doing something. This feels like the wrong logging level, but we will find out. Install will just drop it in your user repo. Oh, build success. Build success, you say. Where did it put it? Oh, it put it in M2. Okay. So I should now have Antler files in here. But that's the, oh, right. I don't want the test suite. I want Antler, probably runtime. Probably the 4.13.3 snapshot. Probably the jar. Cool. So if I now run here this instead, what happens? No main manifest attribute. I love running Java code. Interesting. So maybe it's not just runtime. Maybe I need master. Master sounds promising. Oh, but there's no Java. There's no jar there. Run Maven package the local build with artifacts in target. Oh, see, this is why it's so handy to have Java experts in the room. So I can do package. Antler for tool. You lied to me. There's no jar now either. Where did it put it? Building jar. In tool, target, antler, snapshot. What's the difference between complete and not complete? Riddle me that. Okay. All right, I'll bite. How about this? What if I do the complete one? Is the complete one better? Complete. It did a thing. What did it do? Actually, what did it do? It ran successfully. Clearly, I have not used Antler myself before. Let's go look at what this says. Okay, yes. Yes. Yeah, okay, I ran that. Now what? Did it modify my source main? No. What? Hey, tool, tell me what you did. Okay, well, what if I here do like Java? What happens? I bet you it writes it near the file you gave it or something. Yeah, there we go. Okay. Okay. Great. Okay. Well, we figured it out. So let's seed into Avro and let's do git clean in the submodule to remove those. And then we'll run the Rust version again. Give us Rust. And then we'll ls here. Actually, we'll do this and we'll do ls files. No, git ls, git status. It's too early in the morning. Now the question is, do I need the interp and tokens files or do I just need the Rust files? I'm going to assume I only need the Rust files. So we're going to do move star.rs to source. Let's go look at what it generated. IDL parser. Generated. Great. It generated a whole lot of code. Let's then see whether there's any mention of interp in source. It doesn't look like it. What about tokens? No mention of tokens. Okay. Cool. So we have source files. What else does it tell us? You can also see build RS of one that rebuilds the parser automatically. Oh yeah, there is -o. Great. I don't think I want this to be a build RS. I think I want to check in the files because I don't want consumers of this crate to have the the antler Rust version built locally to be able to run this. So I think I actually want to just check in the generated files. Yeah, that is what I want to do. And this is just examples. That's fine. Okay, great. And then it says add Antler Rust to your dependencies. Okay, that's fine. I can do that. And then so they have an example build RS. Do they also have an example like source lib? Not trivially. Okay, fine. I was hoping they would have examples. Do they have an examples file in this directory? No, they do not. Okay, then I think what we're gonna do is we need to figure out what the entry point here is, which I wish they would document in this README, but they did not. Okay, that's fine. What we'll do then is we'll go to source. Oops. Oh, I don't have a source lib because I didn't tell it I told it I wanted a binary, which is true, but I also want a library. And I want ls source. I want mods for each of these. Like so. Now what happens if I run cargo check? Well, that's also interesting. They tell me to take a dependency on Antler Rust 0.5, huh? Okay. But I think I see a problem. Antler Rust 0.2. Do not use Antler Rust 0.3. Interesting. I wonder if it's this one they mean? Yeah, I think it's this one they mean. Because in fact, if you look at the generated code, if we go into this, for example, you see it's naming a dependency called Antler 4 Rust, which is not what that one is. So I think this is supposed to be that, and that the README is simply out of date. Well, that compiled. Gave us some warnings, but that's fine. Okay. So now we, in theory, have something that looks like a parser. So in fact, let's go ahead and let's cd into Avro first. Git clean this. I just want to commit this init plus generated grammar. And now I think we can, so we can either now go and try to figure out how the parser works, and maybe we probably will have to, because I suspect we're going to have to point Claude in the right direction for how to use this. But I do actually think, for examples, you can see here. Ooh, yes, okay. This is the corresponding generated code. Yes, we've seen a lot of that. And so this is what, okay. So it generates, we pointed it at a grammar file called IDL. And for each file you pointed at, it generates 4 files. Sometimes maybe more than 4 files. That's visitor basic base. Visitor basic. So let's look at maybe CSV. It generated Lexer, listener, parser, and visitor. And it also generated these base. It didn't generate the base. IDL base listener, IDL lexer, listener, and parser. So we did not get a visitor for whatever reason. Okay, that's fine. So the generated files look like they're about right, but now I want to see general tests. So I'm hoping that this will actually show me how to parse one. Yeah, okay. So this uses from the lexer and listener that were generated. Here's a thing that it's supposed to be able to parse. So like this is an XML parser. Right. Okay, great. Yeah, so this shows you how to do use the lexer, how to use the parser. Great. So we have now our reference file here. I wonder what's in gen. Oh, the gen is just the generated code. What's perf? Cool. This looks like maybe it needs some cleanup. I see. So visitors are the ability to have a parser that will let you write code for visiting stuff in the AST, which I don't think is going to be useful for us. This is where it's useful also to go back to the Java code. So if you look at, because it also uses Antler, right? So in the Java code, these files just define basically the equivalent of like source main rs, right, for these two binaries, and both of them end up just calling into they get an IDL parser by creating an IDL over the input file, and then they from there parse out the protocol, and they get named schemas and stuff. Okay, so they just get things out of there, and the IDL is this kind of thing. So IDL file, which is an IDL reader. So IDL reader here, presumably we should see a bunch of the stuff that comes out of the generated parser. Aha. Avro IDL parser. Okay. So where's the generated parser? Do they check that in somewhere? IDL schema parser. Avro parse context. Avro schema. No, that's for parsing a schema. That's not what we want. We want the IDL. Where are these coming? Like, where's the IDL parser coming from? That sounds a lot like the thing that's generated. I just want to see if I can find a sort of natural entry point here. Yeah, this looks a lot like using the things that Antler generated. Primitive type context. I just want to see if they checked in the generated Java files or not. So if we go to lang IDL source main Java org Avro IDL. No, they just have these. So that makes me think that they might not check in the generated the generated parser unless it's under here. Utils. Write IDL schemas. No, this is writing an IDL. This is not writing the JSON or parsing the IDL. So these are just like, I think these are actually helpers for the linter, right? So imagine you want to run a formatter on your IDL schema. The way you do it is you parse the schema file and then you write it back out in a well-defined way. And I think this is the write it back out in the well-defined way. And so this doesn't matter too much to us. I mean, this could also be interesting to port, but it's not the main focus I want to have. I'm just like the IDL reader feels like it's the right one, but this IDL parser, where does the this lives? Oh, it lives in IDL grammar. Okay, does anything else live here? No, okay. My guess is that this generates an IDL parser, and then that's just what gets imported from these other files eventually. And so this is just the use of the generated code. Cool. And so that's similar then to the Rust code that we saw earlier. So like in general tests, for example, which also shows how to use the parser in the, like in Rust, we're not going to get an IDL parser class. Instead, we're going to get these listener visitor types. And this is the kind of stuff where this mapping, if I were to sit down and understand everything Antler generates, and then map what it does in Java to what it does in Rust, it would take me a huge amount of time. It might still be worth it in the end, but this is where I suspect Claude will be able to do very well if we point it at the things we've found so far. So this is where we're going to start. Yes. Okay. Now, one of the big sort of ways to make these agents actually work well for you is to be good at describing the thing you want implemented. So we're going to start with a sort of high-level description of what I'm aiming for. So I want to, and let's give it the path here to the this tool. I want to port Avro / this to Rust in the current, to a Rust binary in the current crate. The grammar for the Avro IDL is described using Antler in Avro / this, which I have already generated Rust code for in source / IDL star.rs. And then I actually think this would be enough to get it started, but I want to guide it a little bit more for how do we want ours to be different. So what I will also point it at is this. So the Java code, it's split kind of weird. So the main binaries are in a different place in the repo from where the libraries for doing the actual processing is. So I'm going to give it this path as well. The actual logic for parsing for the Java version lives in Avro / this path, lives in the files under here. And then what else? I'll also point it at this, which is really just runtime Rust test general. So I'm guessing that this will be here, right? Yeah. Antler this. You can see example Rust code for interfacing with Antler generated bindings in this. So this will be a good example for it. And then we want to give it some example input and output files. And those we want to use these for. And then I also want to see whether there's an outputs. Yes, there is. What else is in this directory? Okay. As test input and output files, use and output for any given AVDL file. For any given set of AVDL files, you can also execute the Java version yourself using, and this is where I need the Java, this one. It's also very useful to give it example commands that it can use to run things itself. And then we can do here, path to AVDL, path to output file. You can also execute the Java version yourself and generate an output file using this. Cool. Let's start it there. And then usually what will happen is it'll come up with a mediocre plan initially. And then we're going to have to, oh, is it an output folder? You can certainly give it just a, what happens if I just do /? Oh, right. I deleted that file. Oh no. Well, now that Maven command works. That's handy. Yeah, it doesn't like that. So it does need to be a file. I think, oh, maybe this one is the one that can output a folder. Let's find out. Maybe that's the difference. Yeah, this does say output directory. So let's see what happens. If I do this, what do I get? Aha! Then I get one file for every type. Okay. There is also, and then we'll give it the path to this guy as well. Which you can pass a output folder, we'll stress folder, to in order to generate separate AVSC files for every schemata defined in the input. And then the last thing I'll do is I'll point it at the IDL language docs. You can find the documentation for Avro's IDL format at this URL. And now let's kick it off and see what plan it initially comes up with, and then I'm expecting we're going to have to do a decent amount of finagling to this. Context filled entirely by prompt? I don't think so. I think we'll be okay. Yeah, you can run WC commands. That seems fine. And then initially, obviously, it's going to prompt us a bunch for, am I allowed to use this tool? Am I allowed to use this tool? And then pretty rapidly, we're going to end up with like a sane enough set of things that are allowed that we don't need to approve things all the time. In the meantime, check the Rust parser files generated by Antler if it has a parser function. Sure. Parser. In fact, we can do, because it's Rust, fn parser in source. Nope. But there might be a parse. That's interesting. Didn't we see this? Oh no, it's that you create a it's like parser new. Well, that's the lexer. Where's the here parser test CSV? You create a lexer over the input stream, then you create a parser over that token source, which is the stream of tokens that comes out of the lexer, and then you add a listener to that parser. The other thing that's nice here is, so Antler is supposed to be pretty good about keeping the parsing context and revealing that to the callers so that you can then give, oh, this is the last thing I forgot to give it, is I want to use miet. Because miet is really good for giving you the ability to point to specific parts of the input. So let's go ahead and do that here as well. I would like to use miet as a way to keep track of lexing and parser errors so that we can give very good and helpful backtraces in the case of invalid input files. By the way here, I think, is a Claude feature where you can give an additional prompt and it doesn't interrupt what it's currently doing, but it will read it the next time it's like in between instructions. Are you running Claude in a VM? How do you defend against information leaking out, such as environment variables and so on? I'm not running Claude in a VM here, but I'm also not running it in YOLO mode, so it has to ask me for permissions for things. In general, the built-in sandboxing is not great, but it's also not terrible. Like the sort of obvious examples of it trying to read outside of the directory that I'm currently in, it tends to ask me at least once. Environment variables, I'm not too worried about. Like there are no environment variables in my current environment that are actually sensitive. Do you use any advanced agentic coding capabilities like Git work trees and agent swarms? Why does it want to look in my cargo registry? Oh, I see, because it wants to look at the code of Antler for Rust. Sure, that's fine. Yeah, so I use... That's also fine. That's also fine. I do use Git work trees, especially when I have... if I have multiple sort of... What I'll usually do is I'll... as I especially read through both the LLM sort of talking to itself and the code that it generates, I sort of start keeping track of a to-do list, oftentimes in an actual to-do.md file. And I'll sort of write down the things that I wanted to do in the future. And then after I finished whatever my current session is, I'll then point it at my to-do file and say, I would like to fix the following things, break them into semantically related changes, then start an agent for each one in a separate work tree. And then that tends to work pretty well. I did not enable team mode for this. I don't even know that we're going to need multiple agents for this initial part. Usually I've found that for the generation of the first sort of core of the application, it doesn't work so well to try to do it in parallel. It works better for things like having them review each other, for example, or if you're working on multiple relatively disjoint features. We're trying to write the initial version of a crate, it usually doesn't work as well. Miet is really neat, but I've always found the actual reporting a bit of a pain to deal with, very poorly documented there. Yeah, but I think the documentation of Miet itself is a little mediocre. Some of it is also that like the dynamic error types in Rust can be a little annoying to deal with because, for example, Miet error cannot implement the error trait. And this is sort of a limitation that's known in Rust, like anyhow and error have the same problem. But if you specifically want to get the sort of errors where you can point back to source code and say like here, then Miet works pretty well for that. And you'll see it's still in the plan phase, right? Because we gave it a pretty involved set of things to look at. And so far it hasn't generated any code. It's just trying to come up with a plan that sort of satisfies the inputs that I gave it. And I mean, we could go in and explore what it actually is thinking about, but instead what I want to do is go back to the IDL language a little bit. So the IDL language itself is like not the translation to JSON is not actually very complicated. So if you look here, like we have a record, so we have type message. It has two fields, title and message. Both are string typed, but the title is allowed to be optional and defaults to null. And you'll see if you turn that into JSON, it's a pretty straightforward transliteration, right? You go from like type is record, so that's from the first keyword, name is message, that's from the second. Namespace is grabbed from the file, so you do need to keep some amount of global state as you walk the file. Fields is just an array of the fields. For each field, you have the name of the field, the type of the field, and a default if it has one. You'll see this type here is an array, and that's to support unions of types. And so the way that Avro represents optional types is that it's sort of a syntactic sugar for a union of string or null. And that's all there is to it. So it's not like there's a super complicated resolver happening here. That resolver lives in the actual Avro compiler, which works on the JSON. So it's just the transliteration from the AVDL format to the JSON format itself is kind of dumb. And we can sort of see this, like if you go to the IDL reader, like there's a bunch of code in here, but much of it is just like invoking the parser and the lexer and then defining a bunch of types that we need. But there is some, right? Like here, for example, they're trying to extract doc comments so that you can add those into the JSON thing. And then you need to know when you have a doc comment in the input file, you need to know which record to associate that documentation comment with. So there is like some amount of complexity here, but it's not a huge amount of complexity. There are also imports that you do need to deal with. So it's like, okay, there's a little bit of annoyance. But like ultimately, this whole file is 1,000 lines. It's 1,000 lines of Java, which is not not the most concise language in the first place, right? So 1,000 lines of code for doing the reading and the writing doesn't seem too bad to me. No, that seems incorrect. You do not want to do this. So let's instead tell it you can find the full source code for all the Antler for Rust stuff in Antler for Rust runtime Rust source. Right? That's what we, yeah. Source. So that it stops trying to look through my registry, searching for things in my entire registry. I was writing a DSL for work a couple of weeks ago and was surprised the nightly trait allocator was not stabilized. Would have made it a lot easier. Yeah, I mean, allocator has been unstable for quite some time. I don't actually know what the current blocker to stabilization there is. Yeah, there's a... I remember for a while it was trying to figure out things like whether dealloc needed to be given the layout of the type that you wanted to deallocate and stuff, but I'm sure they've moved past that now. That was almost a leak. I'm not concerned about leaking what's in my cargo registry. That seems fine. Important finding. Common token stream get is public and accesses the raw token buffer, including hidden channels. We don't need to patch Antler for Rust for doc comment extraction. Okay, good. See, this is where sometimes it's funny to like expand the internal dialogue Claude has with itself, because it sometimes it will like fret over, oh, how am I going to possibly do this? I need this thing. I think a big holdup is seeing if they can avoid a huge explosion with fallible. Oh, yeah. This is basically like, if allocation fails, how do we propagate that information. And of course, someone came up with another alternative. Yeah, of course. And so then the whole saga starts again. Yeah, it's the sort of the eternal question of like, when are you done discussing? Right? When are you done looking at alternatives and you should stabilize the thing you have? And there's no right answer to it. Do you think you're more or less productive with agents in your day to day? I feel like coding skills atrophies, but reading skill improves. I think it's a mix. So I think I do think that the more you use agents, the more your coding skill atrophies. But at the same time, I think there's sort of an upper limit to how much you can use agents for your work. And so therefore there's an upper limit to the atrophy. And what that upper limit is, I think depends a lot on the kind of code you work with and the kind of projects you work on. So there are some parts of the work that I do where like I just realistically couldn't generate the code. Like the agents would not be able to write that kind of stuff. And there's other things like this where I'm pretty sure that Claude will do very well at this. And it would take me a huge amount of time that would not be particularly well spent. And so then I don't really care that my coding doesn't learn from this coding because I have other coding that fills the gap. Should IDL and IDL2 schemata be subcommands of a single binary, or would you prefer separate binaries? I would like a single binary with subcommands, I think. The generated antler files have allow inner attributes at the top, which means they must be crate roots or mod targets. They can't simply be moved into a subdirectory without removing those inner attributes. Should I strip the inner attributes or move them to source generated or leave them flat in source? I'm pretty sure they're fine as they are. Like, yes, it has allow non-standard style, but that's fine. I guess it would, it would like those files to be in a different place. But why would that make you strip the attributes though? I'm fine moving them to source generated. That seems fine. And then the other thing I was thinking of is it's probably going to default to using clap here. And I don't think we need to. I think the input here is straightforward enough that I think I want to use Lexopt instead. Maybe. Nah, it's fine. I'll leave it to choose what it wants. Okay, we have a plan. Let's look at its plan. Oh, it's a long plan. Good. Okay. Context. And this is where well, one of the things that I've found a little interesting about using agents is it forces you to sort of read through someone else's plan, which I think can actually be really useful in the sense of it makes me, I think it has improved my ability to sort of critique my own plans when I come up with one, but also when other people pitch me a plan for what they want to do, it feels similar to reviewing this plan. And I actually think reviewing these plans is really useful and teaches you a bunch of things. It's different from like the kind of teaching you do by writing code yourself, but it does teach you something about planning. And I think it also forces you to think through some of the implications ahead of time, which I think is a good practice anyway. Okay, the crate already has Rust parser lexicode for the Avro IDL grammar, but no actual logic. The goal is to port the Java tools, those, to Rust binary that can parse AVDL files and emit those things. Yes. Core parser logic lives in a IDL reader, which uses the listener to walk the parse tree and build Avro schema protocol objects. We'll port this to Rust using a recursive tree walking approach over the antler-generated Rust parse tree. That seems fine. Now, there is a really interesting observation here already, which is in the Java code, when they want to generate the JSON, I expect that they use, they use this stuff. So they already have definitions for the JSON representation. So we're actually going to need Rust implementations of those structs and then derive serialize for them so that we can produce the JSON, which I'm guessing it'll figure out. We'll find out. Okay, key design decisions. Recursive tree walk instead of an antler listener. The Java version uses the listener with enter exit methods and maintains mutable stacks. In Rust, it's awkward to implement the IDL listener trait due to the lifetime constraints. The listener methods receive borrowed context that can't easily coexist with mutable state on mute self. Interesting. Is that true? IDL listener, parse tree listener. I see. So you're given references to the nodes as the parser walks through them, and you can't easily store those references in self as a stack, because by the time this function returns, this reference is no longer valid. This reference is, but that reference is not. Although that does make me wonder what's in these leaf nodes. Because I actually wonder if we could just extract the tokens directly, because ultimately they should just be tied to input and then be a little bit of information around. Oh, I guess data maybe is the problem. Oh no, or yeah, interesting. Okay, so what does it want to do instead? Instead, we parse with build parser equals true, and then walk the resulting tree with recursive functions. This gives us full control over traversal order and state threading. I see. So this means that it's not going to be a streaming conversion. It's going to be a parse the whole thing, and only when the whole thing is parsed do we walk it recursively. I think that's okay. It's a little unfortunate, but I think working around it's going to be annoying. Rather than depending on the Apache Avro Rust crate, which lacks a protocol type and whose schema serialization wouldn't match the expected output format. Why? Actually, is this the latest one? I remember there's been a rename of one of them. Yeah, this is the latest one. All right, what do we have in here? Yeah, because this this crate schema. And if I look at schema and show me the source of schema. Interesting. It actually doesn't even implement serialize. So Apache Avro is the Rust crate you use for interacting with Avro schemas. So after you've generated the JSON, you want to now use that JSON to generate Rust types and do the serialization and deserialization in Rust. The Apache Avro crate is the one you use for that part of things. And it obviously needs to parse the JSON schema. So it must have Rust representations of the things that it's going to parse. Oh, this derive. What's in derive? And so the schema type here, for example, is basically the type used to represent I think the top level of the JSON file. So the question is, why can't we use that one? Because this should have all of the types you can have for fields and the like. And it has a parse. It might not have a serialize, but this feels like ideally we would just add the ability to serialize to this so that it could use the same types. Although it's not the end of the world. Like this is the output schema is not too complicated. With a purpose-built domain model, Avro schema enum protocol struct that serializes to certain JSON value. This gives full control of the JSON key ordering and formatting. Yeah, that's true. The JSON key ordering is the other thing here because we're expecting this to generate 1-to-1 equal output. That also means that all of the JSON fields would need to be in the same order. The alternative would be that we tell it, we don't require that the JSON is bit for bit identical. We just require that it's semantically identical. So like if you parsed both as JSON objects and then compared to them, they have to be the same. I think for now, I'm okay with us just having these types ourselves. And then we might want to relax the comparison logic down the line anyway. But for now, this seems fine. Comment extraction via token stream get. The Java code calls token stream get hidden tokens to left, which is unimplemented in Antler to Rust. However, common token stream get index is public and acts as the raw token buffer. Oh, that's interesting. Okay. Antler for Rust. Runtime Rust source. Hidden. It's not what I wanted. I want hidden. Hidden tokens to right and hidden tokens to left are indeed not implemented. Cool. I wonder if that is, if we go to the Antler for Rust thing. Oh, we should probably point it at this differences with Java thing. I was just curious whether there's an issue for this. No, it doesn't look like it. What about pull requests? No, none yet. Okay. But I do think we should actually point it at the README so that it's aware of the... Would that be in here? Yeah. So I do want to point it at that in a second. So instead, it's just going to do the common token stream and then walk backwards through the tokens. That seems fine. Miet for rich diagnostics without put with source bands. Custom Antler error listeners will collect errors as Miet diagnostics. Perfect. Module structure. It's going to generate a CLI with clap that has the two subcommands. That's fine. Error types. The model, this is going to be the model for the output schema. So the JSON stuff, that seems fine. Sure. Okay, what do we have in schema? Primitives, name types with name, namespace, doc fields. Yeah, these are basically the things that come from the spec itself. So if we go up the spec, we should find... oh, it's not open container, it's object container. That's the thing I was talking about earlier about arbitrary bytes. Yeah, I wanted to look for... Yeah, so if we look at, for example, record... It's supposed to have name, type, and fields. Name, type, and fields. Although it's interesting because it seems to declare more things in here. I wonder if there's a... Is the complete grammar at the bottom here? No. It's surprising to me that it doesn't have everything in the spec. Name, type, doc, fields. Complex types. Support the following attributes. So where are the other attributes coming from? Okay, so we might have to point it at this as well to say your schema representation might be wrong. Name, because like, for example, the is error and aliases. Oh, aliases is there. Properties. Their properties doesn't seem like a thing. All metadata properties. Oh, I see. So these might be additional keys, but they're not known in advance. So I'm guessing that properties is actually a hash map of those. And when you serialize, you add those into the serialization. Don't know what is error is going to be for. Oh, this might have to do with if you use it in a protocol. That's fine. We'll see what it does here. Arrays are, right, these need to be box Avro schema because we have a recursive type, and so they need to be sized. And in order to be sized, they need to be boxed. That's fine. Same for values. Same for unions. That's fine. This is references to other types that we may not have parsed yet, so we need to store the reference until we've parsed them. Logical types, that's fine. Yeah. Name types is serialized inline on the first occurrence and as bare name strings afterwards. Sure. Cycle permission for imports, that seems fine. All right, what are the errors like? Yeah, we already have Antler for Rust. We'll bring those in. Ooh, I do want snapshot testing. Thank you very much. I think this is from my agents MD. I think I put in that I like snapshot testing. Okay, first move all the stuff around, then add the model, then hand construct the tree, serialize and compare. Then error types, then schema registry. Yeah, the schema registry you need so that as you're parsing types, imagine you have a record foo and a record bar, and then you have a record baz that has fields of type foo and bar. You need to have a registry where you store the definitions for foo and bar so that when you get to baz, you can inline the definition from there or reference them to my name. That's what the registry is for here. That seems fine. Core tree walker, this one I'm just going to believe it because if it gets it wrong, it will be very obvious in the outputs. But it'll generate a top level walk IDL file. That seems fine. Test after each substep against progressively more complex AVDL files. That seems reasonable. Yeah. Main is going to generate 2 subcommands. This will be similar to the existing commands. This iterates over all the name schemas. Yep. Run all 18 test cases. Yes, please. Compare by parsing both expected and actual JSON to JSON value for semantic equality to avoid the formatting differences between the Java and the Rust serialization. Great. So it's already doing the thing we were saying it would probably need to do. Tricky parts. Nullable type reordering. Type creates a union, but if the field default is non-null, the union must be reordered to T, null. The first type in a union must match the default. The Java code uses an internal marker property to track this. We should use an internal flag on the union variant instead. That seems okay. JSON default value fix-up. When it feels default is parsed as an integer, but the type is long, Java converts int node to long node. Inserty JSON numbers are unified, so this is a non-issue, but nan and infinity are not valid JSON. The Java code uses special string representation. Of course it does. Cool. Okay. See, this is the kind of stuff where, like, I'm glad it picked up on this, because this seems like it's annoying to pick up on otherwise. Name type serialization. In protocol JSON output, name types appear inline, full definition, on the first reference in the types array, then as bare string names in subsequent references. The toJSON must track known names to decide which form to use. Some test files reference class path resources. We skip those to provide the files alongside. Okay, so we do need to tell it then about Avro lang. Actually, let me just do this. So there's also what its references to the things that put on class path or other things in here. So we have extra and we have put on class path. And so these are other things where the Java version will know to import these files because they're on the Java class path. That doesn't exist in Rust, and so we need to track them separately. We should probably point Claude at the these extra paths as well so that it's aware of them. Antler string tokens include the quotes and escape sequences. We need to unescape them. Yeah, that's fine. Great. Okay, so we have a couple of notes. Read the differences. What was it called? Differences with Java. With Java section of. No, we don't need that. That's not a URL. In case that holds differences relevant to your plan. Also look at extra comma put on class path, both of which are probably useful when using the AVDL files from the testing AVDL files. And then let's also point it at the spec. You can find the Avro JSON specification here. And I think that's all we really needed to correct here so far. Probably make a small adjustment to the, yes, I'm fine fetching from Avro Apache org in this repo. It's imagining. It might not adjust the plan very much here, but it's also useful to give it resources like this because what we'll do is we'll clear the context and then run it with just the plan. And then URLs like this will be included in the plan so that later on, if it's going through the plan and needs to reference the spec, it now still has the URL and can go look at it. You'll also notice that, like, for example, I wrote also look at this, and I used basically glob syntax for specifying the paths, and it understood what I meant by those, right? Because glob syntax is used so widely that I guess the sort of the model gets to learn what that implies. So you can use a lot of shorthands, like technical shorthands with this, and it just kind of works. Cool. And then I think the next step now is just kind of gonna, let it cook. Because I think we need to start looking at the code it produces, not just the plan, which we needed to actually produce code first. There's one more thing I want to tell it, which is, by the way, here. Because it has these different steps in its implementation plan. After each step in your implementation plan, commit the changes using the commit writer skill. So I have a skill I've put into Claude that tells it how I want commit messages to be written and what I want them to contain. And so I want to make sure that it actually does those commits as it goes, because otherwise we're just going to end up with a giant batch of diff at the very end. Cool. Clear context, auto accept edits. Let's see what it makes. Doesn't it lose the context the more data that's provided or more iterations are done? So kind of. It is true that as you work more in a given session, it will start to, its context will grow large and therefore get kind of diluted. What? Sure. And then start to get a little diluted, which is okay. Because whenever it has to compact the context, it is refed the plan. And this is why it's so important that the plan is well structured and contains a lot of the relevant details, because as the session progresses, it's going to continue to refer back to that same plan whenever it has to compact its context. So the better you can make the plan, the more continuity you will get as it works through. The other thing I want to do here is make use of subagents actively for self-contained tasks so that you don't dilute your own context. Sure, that's fine. Which Claude model is it? This is Opus. I think I'm on Opus 4.6 because I did a full system update this morning. That also included the Claude update that came out this morning, which includes Opus 4.6. It claims it has a solid understanding of the code base now. I mean, it has a solid understanding of the generated code, I guess. Actually, how much code did it generate? I mean, so Antler did generate like 7,000 lines of code of parser. So I am glad we didn't have to write that ourselves. And I mean, it's also like, it's an interesting question of if the Antler grammar and generated had not existed, would it have been feasible to do this task? I don't know. I mean, it probably could eventually generate the correct parser and grammar, but I think it would actually be a lot more work, even though it's okay at generating parsers and the like, in part because there are so many examples available for it. But I do think that we'd probably run into a situation pretty quickly where we would not be able to do this in the allotted time. So let's see what we got. Oh yeah, I don't want jar files to be checked in. Don't check in jar files. And then this can go away. And now this is clean again. Okay, it wants to do a bunch of git moves. That's fine. Having used Antler, the generated code is mostly boilerplate, though. Oh, I totally buy that. I mean, if you look at the... right, it's moved to here now. So if we look at source-generated IDL parser, look through here, like, a lot of this is pretty mechanical. Some of it is just, like, be a parser, right? But it's like, this is just walking the grammar. But at the same time, this is also code that it would kind of have to have generated anyway, maybe in a slightly different form. And maybe when you're parsing a particular grammar, rather than having to create a general purpose grammar parser generator, you end up being able to write much more efficient code. That's certainly true. But even so, this is now a bunch of code we didn't have to write. I do want to cargo add all of those. Yes, thank you very much. Telling it to the examples and to generate a spec for it before generating a parser would probably have worked better. Yeah, I mean, if I did have to make it also generate the parser, I think what I would have done is not start with the whole, like, we want to do the IDL stuff, but just start with, I want to generate a parser for this language, and then give it a bunch of examples and the Java code and everything. And then after we had a parser, I would then go, okay, new task. Now we're going to use this parser that we've built to build the transpiler. Yes, that's fine. That's fine. Honestly, I kind of like writing recursive descendant parsers manually. Tokenizers are a bit more of a pain, but not so much as you think. I know. I like writing parsers. I've done a couple of them. I think I did one or two on stream. We did one on the... there was a Code Crafters writing an interpreter for some language. And there we did write a parser ourselves. We wrote one using, like... I think we wrote a Pratt parser, if I remember correctly. That was a lot of fun. I've written a separate parser for another reason. And I do think it's really fun. It's more that, and this sort of gets back to the, what's the point of coding, right? Like for me, there's some coding that's fun and there's some coding that's annoying. And it's usually not so much about the code that I write. Like for example, sometimes writing a parser is really fun. Sometimes writing a parser is really annoying. And it depends on whether the parser is blocking me from doing the things I actually want to do, right? So if the thing I actually want to do is, you know, I don't know, knit a sweater, but the task I end up doing is shaving a yak, right? Then like the shaving a yak is less satisfying because I'm doing it, but it's blocking me from doing the thing I actually wanted to be doing. Even if normally that yak shaving would have been fun to me if I was just doing that in isolation. Yeah, the interpreter for locks. And I think it's something similar for me here. Yes, cargo build is fine. It's something similar for me here where I don't actually care about writing a parser for Avro's IDL format. Like that's not a thing that I want to spend a bunch of time on. What? There's definitely a Claude skills commit writer. It is simply lying. The skill is called commit writer. So like here, what I really want is to just have this porting thing. Actually use the commit writer skill, please. It's not always very good at doing what it's told. There we go. Yes, use commit writer. If I spent like most of today writing a parser for Avro IDL, that would not feel like a good use of my time, even if I might have enjoyed it if that was the task I'd set myself. But because the task I've set myself is something very different, specifically, I want to just have this transpiler exist, then, you know, that would be, would not feel like a good use of my time. Great. So now it's going to do steps 2, 3, and 4 in parallel using sub-agents. And in theory, they're all independent of another. One of the reasons why I want to use sub-agents here is because the sub-agents get their own context. And so they get to do a bunch of thinking and stuff without polluting the context of this main orchestrator. So it's going to kick those off now, which is fine. The one thing I want to show here is also I had it generate the commits using my commit writer skill. So let's look at what commit it actually generated, because I think a lot of auto-generated commits are pretty bad. That's why I wrote a skill for it. Let's see how this turned out. Move the answer generated files into generated. Generated files previously used inner allow attributes, which only work at the create root. That's just false. Switching to outer attributes. It's probably thinking of create features. I agree. Because they work just fine. But one thing, someone made a point that it tends to be useful to like let the LLM use its own taste rather than forcibly using yours for some things, because otherwise the LLM will keep getting confused down the line, because it assumes, like, let's take function naming. Like if it proposes a name for a function, then that's sort of the pattern match it has done to the most likely name. If I change that name, if I forcibly tell it, no, use this name instead, then when it later writes code that relies on that function, it will also infer the most likely name, and that name will not match the one that was actually used. And so you're introducing additional potential for confusion for the model on multiple points in the future. So sometimes it's fine, like it's useful to go with the recommendation it comes with, even if you don't like it that much, just so to increase its iteration velocity down the line. And then the trick becomes at the end, you can change a bunch of these things around, but you don't want to do it during, because then you're slowing down each subsequent phase of the development. Created stub files for the planned module layout, add runtime dependencies. Okay, it's fine. It's a fine commit message. The agents don't commit because they will step on each other's toes. Instead, you should commit their resulting work at the end. Do you mind spending money / tokens on open source tools? Do you even have it as a consideration, or is Claude Max enough that a project like this doesn't usually use too much of your quota? So the reality here is that I'm normally on Claude Pro because I use it. So at work, we have our own separate setup. So at work, I don't use my own tokens. And then for my personal work, I usually end up not going over it sort of depends what I use it for, but very often I'm able to stay on the pro plan and just stay within budget, so to speak, whatever I use it for, because I use it for smaller tasks. This is an example of a bigger task where I would expect that I would very quickly run out of the pro sort of token quota. And so I upgraded to max specifically for today, because I think I would easily otherwise have used like the tokens allotted to me, and I wouldn't want to like stop the stream for 3 hours until the token limit reset. But I'm totally fine using tokens on contributing to open source things. I would be more skeptical on using it for something that was only going to be private, because it feels like it's not even contributing to something outside of myself. Isn't it harder to go back and refactor a full system instead of doing it on the spot? It's not so much about refactoring a whole system. So for system architecture, I will tell it to do things differently. It's actually more specifically for things like naming, or things where a construct that it constantly gets confused by, where those you might be better off just letting it do it. Like in this case with the sort of after the allow attributes, I suspect that if I left those in the files, every time it would open one of those files and go, oh, this isn't allowed to be here. Or if it hit an error, it might go, oh, but that might be because we have those here and they're not allowed to be. And I kind of just want to remove the distraction. Like, you can kind of think of these agentic agents as having like some amount of ADHD, right? Like they see a thing and they can't really let it go, or they need to continue to focus on it until it goes away. And so I'd rather just make it go away, make the distraction go away. Where do you host your commit skill? I haven't put it in the open yet because I need to do a little bit more due diligence before it's useful to other people. Moral of the story here is don't nitpick. Yes and no. So there are a bunch of things I will nitpick on. Like when we're in planning mode, for example, I will nitpick on specific parts of the plan that I think should be different. But there's sort of a difference here between being very detail oriented and trying to change things that the model will... They're sort of misaligned with how the model is likely to think about the code in the future. I feel like these models have more ADHD than I do. I think that could certainly be true. All right, let's look at the log. Oh, it committed all of them together. That's not what I wanted, but okay. Okay, error, .comment extraction. Yeah, and see now we're about to auto compact in not too long. That's fine. This is the core tree walker. So I'm trying to debate if I want to compact before it runs this. No, I think this is okay. All right, let's look at the code as generated so far. So we now have a bunch of code. Cool. Generated code, I assume, is just going to stay the same, and it's now put all these allows on there. That's fine. The .comment stuff is the thing that will allow you to extract the .comment before a record or a field. Yeah, exactly. So it extracts the .comment associated with a parser tree node given the token index of the start, so of the record, for example. We scan backwards until we find a .comment. So we get a token stream. We get a token index. We keep walking the stream backwards, borrowing it, getting the token type. If the token type is .comment, we grab the .comment text and we break. Otherwise, if it's whitespace, we keep going. Otherwise, we hit something that's not whitespace and not an empty comment. Then we break and give up. Then we return early if the .comment is not set. We strip the prefix and suffix. This seems wrong. Maybe not. Maybe we're actually guaranteed that these are... This is an example of something where I would probably prefer a debug assert here to check that that's actually what's going on. So let's start with one of my favorite things, todos.md. And so this is... And part of this is because I don't like sending all of these nitpicks to the LLM while it's doing something else, because it tends to, again, get distracted by it. So instead, I'll keep this to-dos file and then at the end point it at this and be like, here are a bunch of things to tidy up. In this, when stripping the and add a debug assert to make sure that what we stripped was actually those characters. Maybe use strip prefix and friends. If trimmed is empty, then return none. Yeah, so an empty .comment is equivalent to having no .comment. That seems fine. And then it strips the indents. This is matching the Java strip indents behavior. So let's go look at the Java strip indents. Yeah, so this is just when you have a doc comment, the left side of every line is going to have like space, 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 star, space, and then text. But when you generate the actual doc comment, you want to strip those and instead like rewrap the text to not have those spaces and stars. And that's what this does. That's also presumably what this one does. Does this bring in the regex crate? It doesn't. It feel like it probably should. Yeah, let's tell it to use regex for this instead. To make it better match the Java version. Let's prefer doing the stripping with the regex crate to match what the Java version of this code does. It's still going in the background. Yeah, while the tree walker agent works, let me prepare the import resolution and CLI modules in parallel since I can write them independently. Cool. Sure. Go ahead. And now it has to compact the conversation. That's fine. Okay, so this is going to change because we are going to switch it to regex, so no use in reviewing that right now. And then it has a bunch of smaller tests. I think I'd actually prefer those tests to be expanded. Also, let's expand the set of test cases for strip indents. Cover more odd combinations of characters people might use in their source code. AVDL source AVDL code. Okay. So that's the doc comment parsing stuff. What else do we have? So next we have the error types. What's an error? It's a named source. So this is new, I think, because it used to be that you had to like specifically include the named source, the whole source string. Utilities start from every regular source code type that doesn't implement name. What do you mean doesn't implement name? Interesting. Because the source code is just like a string, but I'm guessing then, I'm hoping that what it does here is deduplicate, right? So, oh, maybe the source code here ends up being oh no, it is just over string. Interesting. Okay. Label, message, span, okay. IDL error can parse. Diagnostics, IO, other. Yeah, this feels like it could probably be tidied up. Okay, so there's not very much logic in there at the moment. Import resolution. The import IDL case is not handled here because it requires calling the IDL reader / parser. Oh, I see. Because these will actually import the JSON files. Whereas this imports the IDL parses it, turns it into JSON, and then imports that. Interesting. Yep, that's fine. Resolve import. So it resolves relative to the current directory. Otherwise, it checks the configured import directories, which would be equivalent to the Java class path. Oh, interesting. I wonder whether it's even necessary to, like, because this basically has to parse the JSON representations. But I guess that's fine because we must have types to produce the JSON representations. So we're fine to just deserialize them as well. Doesn't mean we need to understand their semantics though. So what does JSON to schema do? Converts a JSON value to an Avro schema, where Avro schema is our wrapper type. Okay. I see. So we can't actually just, Serde deserialize into Avro schema because why? Because of things like name type references. And we want to represent unions. Okay, I see. So we have a custom way to turn a JSON value into a parsed schema. That seems fine. And then for the name, we have the references. We turn them into references. Okay, that seems fine. And I think AVSC and AVPR here are actually very similar. So the AVPR just pulls out the types of messages. AVSC I see. So they both just register the schema. I see. Messages here are, so in the protocol, messages are the API endpoint, and then the registry holds all of the schema, all the schema types. So in the case of being given a protocol file, we have to parse out all the types and list the messages. If we get an AVSC, all we have to do is pull out the types. So that makes me curious what register does, which I think just is going to go to the registry, which we haven't looked at yet. Okay, and a lot of this is just parsing stuff. That seems fine. It does allocations here that we probably don't need it to do, but that's okay. Yeah, and a lot of this is like parsing the complex types, not in the sense of parsing the IDL representation or parsing the JSON, but parsing the JSON structure. Yeah. Logical type. Yep. That seems also reasonable. Whole object extra properties. Yeah, I think I would definitely prefer to handle. So you can define your own logical types in Avro. And when we get those, I would want that logical type to be preserved in the translation as well. So handle the to-do around unknown logical types in source import.rs. We should make sure to always preserve custom logical types in conversions. Primitives with no logical types. Any extra keys beyond type are custom properties that we cannot currently represent on bare primitives. So properties here are things like annotations like ampersand order, for example, not ampersand, at order, where you can say what ordering that field type should have. I do think we want to make sure that we keep track of additional properties on primitives to always preserve additional properties. Primitive for stir. This feels like it should return an error, not hit unreachable. Should probably return an error rather than panic. I assume the Apache Avro crate already has done legwork translating Avro concepts to Rust concepts like types. Are we missing out on free context and compatibility by not referencing or integrating? Also, JSON parsing and validation should already be in Apache Avro crate as well. So kind of. There's two problems here. One of them is that the Avro crate, the Apache Avro crate, does not have support for serializing the JSON, only deserializing, because that's all it cares about. The second is that turning the JSON types into Rust types, the need you have is a little different when your goal is to produce these files and be able to like combine them with a parsed input schema, for example, like an IDL schema. So maybe there's a path where we could join in with Apache Avro here, but not off the bat, like because their types are not built for producing these JSON schemas, only for consuming them and then doing code generation based on them. Okay. This is parsing JSON messages. Great. How's this going? Status AU, that's fine. Let's go back up. Model, we already... Yeah, so this is similar to the code for serialization. So this is the stuff that's not in Apache Avro, right? Taking a schema and turning it back into the JSON representation, which is unfortunately not just a sort of serialize, because you need to do things like preserve the namespaces. And you also need to do things like after the first time you referred to a name, the first time you refer to a name, you must include its definition, but the subsequent times you refer to it, you just refer to them by reference. Okay. This stuff feels like the structure is about right. Well, when I'm reviewing this code, I'm not so much reviewing like every line to check that it's correct, because a lot of that we'll get out of the testing. I'm reviewing whether are there sort of obvious things that don't seem to be handled. I'm looking for, are there structural things where I think the code shouldn't be operating this way or handling the inputs in this way. I'm looking for things like error handling, panics, unwraps. I'm looking for, yeah, I think those are sort of the main things that I'm looking for here. You'll also notice the way that it's writing comments for me here is a little bit like literate programming, and that's on purpose. That's also something I have in my ClaudeMD, in my user file, is that I want comments to specifically help me read the file top to bottom, rather than commenting completely useless things. Yeah. And this stuff too is like non-trivial serialization, right? It's like if you're in a file that's in the same namespace as the namespace of the type, then you just want to include the name. You don't need to repeat the namespace. Okay. These are just the definitions. These are also just the definitions. Reader. It's fine. Yeah, this is the core part of the parser. Walks the parse tree to build our domain model, which is the Avro schema stuff. That's funny. So it does choose to use module level allows here, and here it thinks it's fine. But this kind of comment is an example of a very like literate programming, right? Of write out what is about to happen. That's fine. All right, this seems worth reading through more carefully. So this is the top level of parsing the IDL. So we get our input. We pass it to an input stream new. This is the antler generated stuff. Give it to the lexer. We create the token stream from it, and then a parser from the token stream. We do build the parse tree. This is the sort of limitation. This is because we're not using the listener pattern. The input field holds the token stream for doc comment extraction, unfortunately. And then we walk the IDL file. This is the thing that starts the recursive. So remember, we're basically doing a recursive descent over the parse tree here, rather than using the sort of visitor pattern. Accumulated annotations from the parse tree. So this is stuff we need to keep track of. They're consumed by the walker, not passed through as custom properties. All other annotations end up in the property maps. I see. So there can be custom annotations and there can be well-known annotations. So we want to separate those. So that's this bit. And then, yeah, so this is walking the list of all the properties that annotate a given field. And for each property, figure out what the property is and extracting the information. This feels like an error. So in it should probably be an error if there are multiple namespace annotations on the same item. Aliases is just pushing to the array. That seems fine. Error handling here is pretty decent. Although it sort of depends what ends up happening to this error, right? Because we would want this error to be annotated on the part we're actually parsing right now. So we'll have to look at that call stack. So I want to find, where's this called from? That doesn't seem right. Okay, so we need to make sure that errors that occur during parsing and interpretation end up with sufficient context for the user to understand where the error originates in their input files. For example, the error cases in this function should probably also produce Miet errors that point to the relevant, to the tokens that triggered the error condition. So this is going to be a bigger challenge, I think, for it, but find out. And then we have walk IDL file, which is the start of the recursive descent. And then we either walk protocol. Right, so protocol allows you to also have messages defined. Interesting. What is this looking for? This is looking for the doc comment for the entire parse tree. So this is the top level docs. Interesting. This doesn't seem like it'll be right, because this is looking for the doc comment at the top of the input file. And it's trying to get the token index for the start of the file and then extract doc comment. But get token index here presumably will be 0. And extract doc comment tries to walk backwards to find the previous doc comment, but there won't be a previous. I think this needs to be handled specially. I think we'll end up doing the wrong thing, because it will call this with an index of 0. And then that function will look earlier in the file for doc comments, but not find any, since there are no tokens that precede index 0. We probably need to handle looking for the top level doc comment especially. Okay, and then it walks properties. I see. So for protocol, the expectation is, and we can go back and look here at the IDL language definitions at the bottom. They have an example of protocols, right? So the expectation is there's a doc comment at the top, there's another doc comment, and then properties for the protocol. They expect the protocol to be the only top level thing. And then inside of the protocol, you can have additional stuff. And so that's what this is trying to do, right? It's first trying to extract the doc comment at the top, then trying to read the list of schema properties, then trying to get the protocol name. So something here is not right. Oh, this might actually end up... It could be that start here is actually the doc comments are considered hidden tokens. And so when you ask for get token index, you don't get the... or start, you don't get the first hidden token. You get the first non-hidden token. That could very well be. Or is ctx.start... going to skip over the doc comments. The header comment is not a doc comment. Oh, that's not a doc comment. You're right. So in that case, actually... this is kind of wrong in the first place, right? Because this then is extracting the doc comment for the protocol, but how can it do that here unless start points at the protocol? It must be the case then that the parser, when you run it on something like this file, the parser's first token or item is going to be this. And that's sort of where it's pointed. And so when you then look here for, when you look here at start, that's where it's pointed. And then this will look for the first thing before that. And so then, and this is just a comment. So this is not actually a doc comment at all. So then let's rephrase this. Will this do the right thing? Won't it call this and then... So this is more of a, hey, go check your logic again. Okay, what else do we have? Then it walks the properties, gets the identifier. But here's another example of like somewhere where it's not actually preserving the error context. So let's go back to this. A similar problem occurs in when it hits we need to be more rigorous about this to try to indicate that there are other places where this is needed. In fact, or missing protocol body across the code base. Then it gets the protocol body, collects the imports from the body, collects the schemas. Walk named schemas in the body. So this is these, right? Named schema declarations. No. This is collecting the imports. This is walking the named schema declarations, which are things like this. We collect the top level schemas directly into types rather than pulling them from the registry, because the registry flattens all named types, including those nested inside records. The Java tools inline nested types at their first reference point. Only top level declarations appear in the types array. We collect the top level schemas directly into types. I think I see what it's saying. So when walking these, we could have the option of taking all of these and just adding all of them to the registry. And then the list of types, when we turn it into JSON, would just be all the types in the registry. But that would be incorrect, because whenever we put something in a registry, we really put a potentially nested type definition into there. And the registry will store all of those by name flat in the list of registry. So if we then later walked the registry, we would end up with the nested types as well. But the types array of the JSON representation should only, of the types array of a protocol, should only have the top level names, named schemas from that protocol. It seems fine. And then walk the messages, which are these, for example, like all the function calls, sort the messages, produce the types. And then hopefully walk named schema is very similar to what we do in the not walk a protocol case. So then we walk namespace declaration, collect the imports, and then it also calls walk named schemas. Yep. In schema mode, we register them in the registry, but don't collect them into types lists because there is no protocol. If there are named schemas but no main schema declaration, return the first one as the main schema. That's fine, but so the third argument here is the registry. What does this pass? Oh, I see. So this also reads them into the registry. It just stores the information about the top level thing that was walked. So if we go to here, presumably it returns the top level schema that it parsed in addition to adding it to the registry. Okay, that's fine. And then walking a record. First thing we do is we walk backwards in the parse context to get the doc comment. This bit is interesting. Like, what is the use of is error? So clearly there is an IDL error type. Oh, aha. This says error instead of record. So that's what we're keeping track of. So error and record have the exact same structure, so we don't want different enum variants for it. Instead, we just keep one enum variant for records, and we keep track of whether it was an error or not as to how we reproduce it again. That makes a lot of sense. Yeah, so this is just including the fallback. Save and set the current namespace for field type resolution inside the record body, then restore it afterwards. Yeah, so this is, if you declare a namespace on a record and inside of the record you declare new types, those new types should inherit the namespace of the record, not the namespace of the file. That seems fine. Restore the namespace. These are variables, so these are basically fields. Why are there default docs? What is a default doc for a field? Default doc. Oh, the doc comment on the field declaration acts as a default for variables that don't have their own doc comment. What's the difference between a field and a variable? What is a variable in this context? A variable declaration context. There's no mention of variable in the IDL language spec. What? What? But it's in the Java code too. I'm just confused. Yeah, a lot of these look very similar. This is the same of fallback. This is the default symbol. Okay, that's fine. And these, yeah, all of these so far, they have sort of roughly the same issues, right? That they all lose the parsing context. We may need a helper here that should be widely used. Oh, and then there's a whole bunch of parsing. Curious why. Interesting. I see. This is like, okay, this is parsing string literals. Well, isn't there a I'm pretty sure I saw something about, was it escape that was added? Escape ASCII. But I thought there's an inverse of this. That was like, that was basically like parse string. Oh boy. Oh boy. What have I gotten myself into? This file's too long. ASCII. I guess not. I was pretty sure there was a parse escaped ASCII in the standard library as well, but it wouldn't necessarily match what we have. Yeah, I mean, this is just parsing string escapes. Yeah, okay, so eventually we need full octal escape handling, sure. This feels like something we could probably, this feels like it's not that Java specific and it's actually just kind of standard escape string parsing. I also don't know that, it's interesting. It's an interesting question whether the expectation is that the IDL spec is string literals have Java string literal semantics. That feels like not really a sane thing for an IDL to specify. Like, if we go here, is there a mention of Java apart from those? All Java style comments are supported. Java style annotations. I see. So here's an example of custom properties, right? It's things like Java class. But I don't see any mention of string. Let's go to primitive types. Why doesn't my, oh, right. Primitive types are the same ones supported by the JSON format, huh? I see. String. Oh, this is how they're encoded on the wire. I don't care too much about that. JSON encoding. Well, but it's like, it only applies to the default thing. So what I want to find are transforming into parsing canonical form. I think they just don't say. What if I search for like, yeah. I think they're just gonna go, yeah, it's whatever Java parses strings as. Interesting. Okay, fine. We'll leave this parsing in for now. Parsing integer literals. Okay, so we're just re-implementing Java's decode functions. And I mean, it kind of makes sense why we ended up this path, right? Because we told the LLM we want to match the semantics of the Java code. And furthermore, the spec doesn't say how integer literals in the IDL are encoded. It just says they're integer literals. And then the Java implementation of AvroTools' conversion of IDL to JSON schemas just uses the Java parser. And so the result is that the spec semantics are what the Java parser is for literals. And so we need to replicate that here. That's not great. I'm a little tempted to just like sort of special case this and say for integers, for example, we're just going to parse it with the Rust integer parser. And if they're a little different, they're going to be a little different. Well, for what it's worth, that is what we're doing, actually. We are using the integer parsing here. But I thought the Rust integer parsing, maybe it doesn't accept like 0x and the like. Okay. The rest here I think is going to be test covered. And then going back up from reader, where are we now? Resolve. Right, so this is the registry. Registry I'm not too interested in. It should be straightforward and also should be well tested. Okay. For test scripts, create them as examples in examples and run them with cargo run examples. Claude, for whatever reason, really likes creating like standalone .rs files and then running like Rust C on them and then building them rather than just using examples and running them with cargo run. And it's pretty frustrating. So I keep having to tell it to not do that. Okay. Has it generated any? Yeah, okay, so it's generated a new commit for us. Add IDL reader and import resolution. It uses the listener. Yeah, this is a repetition of this. Covers all of the various parsing. Known limitations. Properties and primitive types are silently dropped. Unknown logical types are silently dropped. Unescaped Java only handles single-digit octal escapes. And nullable union property targeting doesn't account for reordering. Interesting. So session MD is something I've added to also my Claude MD that basically outlines whenever you run across something interesting, put it in this file. And so if we go look at this, it'll say, yeah, like here's one example, here's another. Yeah, many of these we already have to-dos for. This one's kind of interesting. Walk record receive a register parameter but does not use it. In the Java implementation, records can contain nested named schema declarations. This is not yet handled. Messages from import protocol statements are not merged in the current protocol. Types are registered correctly, but the imported protocol's messages are discarded. Yeah, so certainly many of these are going to be to-dos. Source of full qualified name, but should use a simple name with reference in the same namespace. This causes many integration test failures. Good. Messages without throws should not include an errors key. So this is actually something where, that's fine. I'm going to copy sessions to a recheck.md because it's going to keep modifying sessions as it works. And so I want it to make sure it goes back and checks all the items from there when it finishes its first iteration through here. I don't see this workflow more productive than the regular programming. Know the speed at which you program. I actually think it is. Like, if we look at no, /. Like, okay, let's exclude the generated code here. So the generated code is about 7,000 lines. So it's generated about 5,000 lines of code. And reading through what we've done so far, like this is just me reading the code, right? There's way more written code than what I've read so far. And I would not have written it faster. There's just no way, right? The interesting thing, I think, is what comes next. It's at the end of the sort of first iteration here and then going back over the to-dos, does it actually get to a working implementation? If it's the case that I now need to spend the next, 6 hours basically redoing its implementation, then I agree it would not be more efficient. But I don't think that's going to be the case. You see, it's already now doing, it's debugging its own implementation already. And this is where it's fun to go back and read its own its own chats to itself, because wait, let me check. Are they defined as separate top-level declarations, or are they forward references? Let me check the input file. Oh, they are top-level declarations. The issue is the ordering. But wait, are they actually reference nodes? Let me check. It's very entertaining to read through. But this is what I mean by it's really, really useful to give it the ability to test its own implementation in a pretty rigorous way. because now it can go, oh, the Java parser handles this. Our parser needs to handle its case. Let me see how it checks it. And now it has the reference to the Java code and the reference to the input and the output and the difference in the error. And it can print the parser representations, right? And so as a result, it gets to iterate without having to ask me a bunch of things as it goes. And actually, what I want to do here is stop it. Stop it more. Stop. Here's what I want to do. Resume the concurrent agents. Also spin off agents for do this debugging in a subagent. Also spawn subagents to investigate, but not fix the issues identified in, what did I call this file? Recheck. In recheck.md and todos.md. When all the agents have concluded, split the identified changes into those that can be worked on in parallel without So the danger here is because we don't yet have a thing that compiles and runs end to end. If I tell it to have many agents that all try to fix things at the same time, they're going to step on each other's toes, either in the form of modifying the same files, or even if I tell it to split them in that way, those agents will, like, if one introduces a syntax error in the Rust code it generates, the other will try to run its code and go, oh, it doesn't compile because of a syntax error. And then they start stepping on each other. Concluded, let me know the state of affairs. Because what I want to get to here is for us to commit an implementation that has, if we look back here, there are a bunch of diffs in here, right? And what I want to do is commit them so that we end up with a clean Git state, and then we can start issuing work trees for the different agents to fix their individual sub issues. How does it make me feel that it's more productive for me to not write the code myself? It's fine. But the point, and I've made this point in the past as well, right? Is it's not as though I can have agents just do all my work. That is just not the case, like empirically. Instead, there are some tasks like this one where I can have like an agent do a lot of the work for me because of again, going back to the start of the stream, right? Like why I think this particular problem is so well suited to solving by an LLM. Because of that, it works really well here. There are other things that it works much less well for, where it is definitely not more time efficient than me doing it. And so, it in a way, it feels better this way, because the things that I need to use my like active brain power for end up being the more interesting things. And then the things that are a little more mechanical maybe, or boilerplate or something, I can sort of offload and not have to do myself. Or, I mean, at the same time, if you've observed the stream over the past, 3 hours, right? It's not as though I just like started it and then walked away, right? This still requires me to walk in and look at the code, leave these to-do comments, guide the agents, come up with a plan. So it's not like it's completely hands-off. But there will be a point, probably pretty soon, where we can just have it sort of run wild and just debug itself. And then we'll have to do another iteration of reviews of like, okay, what does the code look like now? What kind of insane workarounds does it come up with? And so that is where it can be really useful to, like, for example, there was a time when I had to work on something kind of similar, and I kicked off the agents, and then I went and made lunch, and then I came back, and then, you know, it had done stuff while I was having lunch. And that is very useful. It only works for the subset of problems where you get to have this, it has enough ability to iterate on its own without your direct involvement all the time. Is this Claude Code CLI with a Pro subscription? So it's yes-ish. So it's with the Max subscription right now because this is going to be a decently long stream. And so if I had the Pro subscription, I would probably run out of tokens. But so I upgraded it to Max for the purposes of this stream. Normally though, Pro is fine for me for the stuff I do on my personal time. On work time, when I use it, I will use it in more of this sort of relatively intense fashion for a subset of the work that I do. But at work, we have a separate setup where it's not Pro or Max or anything. It's like a separate, you know, separately hosted infrastructure and sometimes different models and everything. Why did it make code edits? I told it not to make code edits. The debug agent is stuck in a loop. It's being denied bash permission and keeps retrying. Yeah, okay, great. Yeah, that's fine. Why did it... I told it not to try to fix anything. I told it. Yeah, but I don't want it to fix anything. And then my plan here is once this finishes, I basically wanted to write out a documentation of all the now known issues that need to be addressed. And then I wanted to commit what we currently have. And then I want to create a bunch of workspaces for agents to try to solve each of those sub things that need to be dealt with. Don't try to fix the issues right now, just identify them. This sort of aligns actually with something that I've thought about more broadly, which is my philosophy when it comes to meetings. So for meetings, I tend to have this philosophy that either you can spend a meeting identifying many problems, or you can spend a meeting solving one problem. You cannot do anything else, and you cannot do both. And you better do one or the other, because any other meeting is not going to be useful. And I actually have come to the conclusion that I think this is very similar to working with agents. That I think you can either have one agent try to find many problems, or you can have one agent try to solve one problem, but you cannot have them do both. And you cannot crucially have an agent try to solve multiple problems. It tends to run out of context, get confused, lose track of what we was doing. And so this is where the subagents thing works pretty well, because you can basically say, I'm going to spin up a bunch of agents, and each agent is going to either do problem analysis and like be a debugger and a problem identifier, or it's going to try to fix a specific issue and nothing else. The borrow checking rule of meetings. Yeah, exactly. If you weren't as experienced as you were, would you consider this work you're doing now dangerous because of the scrutiny you're applying would be beyond a high percentage of users? Maybe, I think is the answer here, because and this gets back to why this is actually a really good use case for LLMs, is because we have such a good reference point, right? Like we know what a correct implementation looks like. It looks like something that exactly maps to this other function. And we have a bunch of test cases and can generate more. And so it's very difficult to end up with a solution that's just incorrect, but that looks correct, which is the normal problem you have with LLMs. Okay, so now it's identified a bunch of issues. Great. So here's what I'll do. Let's first commit the let's first commit the currently pending changes. Use the commit writer skill and consider splitting the changes into multiple commits. Actually, no. Let's first document each of the remaining issues into a .md file. Into separate MD files in issues. Then I want to do that first because I want to make sure we preserve the context for it. Then commit the currently pending changes. And we're just going to do those two first. Because I like having this sort of directory where you keep track of the issues, because then you can say, create an agent for every file in this directory and tell each of them to read their file to figure out what they need to do. And then separately we can, and for each one, create a Git workspace that thing will be operating in. Can we assume the string literal and integer literal definitions in the G4 are okay reference in place of the Java built-in parsers? Let's go see. Probably. Well, although if you look at integer literal, I would assume that the G4 grammar here is accurate. Like I don't think we actually need to support everything the Java one does. I'm guessing what they found actually is that the Java one is a superset of the rules that are in here. So in fact, if we look at this, there's no support for underscore, for example, in the integer literals here. So actually, maybe we can simplify the issue. So let's go here and say, by the way, for parsing the various kinds of literals, check the G4. That's a good insight. Check the G4 file for the possible syntax for such literals. We don't need to accept anything the Java built-in decode functions support, only what the grammar says is legal. File this as another MD in issues for us to address later, because otherwise Claude tends to be overly eager about going to try to fix it right now. So now we should start getting files and issues here. So if we go to issues and we look at number 1, for example, the enum status and status schema AVDL has namespace none, and the parse model, the expected output is namespace system. Yeah, great. So now we're going to start to get a bunch of these that hopefully can be handled relatively in parallel. If you were inexperienced, would you have exclusively used Claude for all your personal projects? Would that have made you learn programming on your own? It's a difficult hypothetical because I really like writing code. Like, I wouldn't want my entire day to be prompting agents and reading code. I want to write code myself. And that especially applies to like the kind of really tricky code that I think agents are pretty bad at writing still. Like concurrent algorithms is a good example of this. And that's the stuff that sort of motivated me for why programming is fun in the first place. I do think though, like for example, I entered programming through web development. I wanted to have a website and I wanted to like program things in it, and it seemed fun. And it could be that like that passion hadn't been started if I could just prompt LLMs to build it for me, because I wouldn't have really known to dig into the code. So I do think there's maybe a danger there that fewer people get exposed to writing code, and writing code could be something that they found really fun. But I don't think I would. I think once you get a sort of taste of writing code and find that you enjoy it, you wouldn't then go to, well, now I'm just going to use agents for everything, because sometimes you write code because you enjoy writing code. Like I do feel like the part of my brain or the brain process I use for writing code is different than what I use when prompting and reviewing. They're related, but they are distinct. And I wouldn't want to not use the coding part at all. Do agents perform worse in Rust if they write unsafe code because the compiler feedback is more limited? Kind of. So the feedback mechanism for unsafe code is worse, but Miri is pretty good these days. So if you give it instructions to run Miri will more often than not be able to tell it, oh, but here you're doing something illegal. And then sometimes it can figure it out. It's more that the domain of problems where you use unsafe are also domains that are harder for LLMs in general, because they rely on more sophisticated understanding, which they don't usually have. So not so much. Wouldn't that cause issues with files that work with the Java parser but fail with the Rust one? I can imagine that causing compatibility problems with non-spec compliant schemas. Yeah, so maybe. So I actually think, because Java also uses the antler generated parser, if you had a literal that used a Java or Rust specific parser thing, it wouldn't pass the antler grammar parser. So you wouldn't, like, it would fail to parse in the first place in both Java and Rust because it doesn't match the grammar. Even if it had matched the grammar, the parser would have parsed it correctly. So that I'm not too concerned about. All right, so now it's doing the commits. So now we should have a bunch of issues. And now we have number 16. This is the one that was pointed out in chat. Literal parsing should match grammar, not Java built-ins. Currently tries to handle the full set of Java escape sequences. However, the antler grammar defines the exact set of legal literal syntaxes. We only need to accept what the grammar permits, not everything that Java's string decode or similar built-in support. Yeah, great. There's one more thing I want to do in git add is fine. You can run git add. There's one more thing I want to do in the context of this Claude session, which now has a lot of context from us working with it a lot. I want it to write a Claude MD. Because I think there's a lot of context from it having built the first implementation that should go into the into the Claude MD because they won't be obvious to someone who just looks at the code later on. So once it finishes this, I'll have it generate a Claude MD, and I'll also want to make sure that it generates in the Claude MD, it also includes references to many of the most important files that we gave in our initial context here, right? So things like the URL for the IDL spec, the grammar file, like all of these paths, which would be pretty annoying or would be hard for Claude to find later on. Great. So now we're getting closer to a clean check-in. It's also going to check in my todos.md and my recheckmd and my sessionmd. Probably don't need all of those. Great. Compacted just after creating the git commit message. That's what I like to see. Did it actually run the commit? Yes, it did. Okay, so now I'm going to git rm, recheckmd, and todos. Actually, todos.md I want to keep because it's still a very handy way for me to just keep notes as I review that I can then later tell it to turn into separate issues and the like. So I'm actually going to do this, and then I'm going to amend that into the previous one. LLMs tend to have a kind of style they write code in, and as someone with strong opinions about the code, I find it frustrating to pair program with them. So this is, there's two parts to this. One of them is you can make it change how it writes code. Like I've done this pretty aggressively. So I don't have a fully up-to-date one here, but like I have a Claude MD that I spent a bunch of time on for how I wanted to write Rust code, frameworks I wanted to make use as, how to write compile fail tests, how to use Git, how to write like preferences for how to do code style and comments, you know, things that I wanted to avoid or make sure it uses. Like I document the XY problem as something that it should be aware of. And so these things you can use to actually make it better at writing and reasoning about code in the way that you want. Like literate programming is a big one for me that I think makes it write code in a way that's much more aligned with how I think it should be written. And then the other part is, and this was, I made this comment earlier today that I try to not impose too much stylistic preference on the LLM, especially when it comes to things like naming and locations of files, because the recommendation it makes is also what its future self is going to predict. And so if you forcibly change what it does now, the future prediction will be wrong. And so it'll be slower in the future. It'll make more like mistakes in terms of identifying functions, locations, files, that kind of stuff. And so it tends to be a sort of, I don't know if you have this expression in English, but in Norwegian, it's called a bear favor. To do yourself a bear favor is to do something for yourself that's actually a disadvantage to you in the future. You just don't know it yet. Okay. Here's what I now want. Let's write a claude.md for the current project, incorporating all the insights you have accumulated over this session. Make sure to include references to useful files and directories in Avro and impl for Rust, such as, and then I want to do this one and this one. And that was less interesting. And so these are both in Avro. Avro, impl for Rust / this. And this and this. Also include links to relevant online references. We should also link to and this. And the reason for this is when I'm going to exit this Claude session and start a new one with like fresh context and everything. And I wanted to then have a decent starting understanding of the entire project so far, rather than have to discover it as it goes. And we're now in a pretty good place for it to create that initial documentation, because it has been writing all of the code that we have in here. So let's see what we get out of that. We should end up with the Claude MD. And then we can start to split the remaining issues work here into separate agents that can then figure out what's wrong. We can also start a new set of agents whose job it is to just run the current one on various AVDL files and identify new issues that sort of get added to the task queue. And in fact, that's something I might start over here after this one runs. So once we have the Claude MD file, to say, start a bunch of agents that are going to document new issues in the issues subdirectory. Its to-do list is... it's lost track of its to-do list because I told it to stop somewhere in the middle where it started like debugging a particular issue. I'm like, this is not your job right now. And then it lost track of its to-do list. You already use Apache Avro. Can you briefly talk about it? I introduced what this was like, what Avro is for and stuff at the beginning of the stream. So you can like rewind to there to look. But yes, I am using it for a couple of things that work. Isn't yielding to the LLM's preference causing maintenance issues downstream? Like if you don't like the code you read, you will probably have a bad time debugging issues later. Yes and no. So it depends on how strong your stylistic preference is, right? Is it for a really good reason, or is it just you kind of like it better that way? And the other is you can always make the change after all of the agent stuff is done. Right? It's just, you shouldn't try to correct during iteration because it makes the subsequent iterations slower. But after all the iterations happened, then you could feel free to like go rename all your function calls and everything. That might be okay. Great. It seems to maybe have, I think it's it's added mentions of like, all of the issues maybe, which is like kind of weird. Okay, great. I think that's fine. Add claude.md. Okay, and now I'm going to exit this one. And then we're going to start one here. And we're going to start one here. This one, start many agents, many sub-agents, each of which should run the current implementation of the IDL tool on known AVDL files from under Avro. Start many subagents, each of which should run the current implementation of the IDL tool on known AVDL files from under Avro / You can't see that part because it's behind my face. And compare the output to the expected output when running the Java tool. Oh, did it document how to run the Java tool is the other question. Yes, great. And compare the output to the expected output when running the Java tool. If discrepancies are found, the agent should do first level triage of the observed bug and then file an issue under issues. The agent should not attempt to fix the issues and should prefer to debug issues using Rust example files in examples that are run with cargo run example. They should avoid changing the source files as much in source as much as possible to avoid stepping on each other's toes. Okay, and then for this Claude, we're going to enter plan mode as well, and we're going to say Bradley, you don't need to worry too much. We're doing a lot of code review in this as well. This is also specifically because for this particular problem, as explained earlier in the stream, I actually think agents work really well. There are a lot of problems that they do not work well for. So it's not like my coding streams are going away in the traditional form. Okay, so for this one, what I want to do is for each issue identified in issues, start a subagent with its own Git work tree to debug and fix that issue. Now, I think there's an interesting question here of make sure run those agents all in blocking mode. The reason I want to run them in blocking mode is otherwise they can't prompt for permissions, and they're going to need permissions for things like cargo check, cargo test, various bash commands, and they'll just fail and then get nothing done. And then I want to include the same thing I wrote here of using examples. Great. Hey, Steve. All right, so let's see what that comes up with. So the idea here is basically the current checkout of the repository, like the main one we're in, is going to be the sort of clean copy that we're doing analysis over, that we merge things into. And that's also where we're running this set of agents that are going to identify more and more problems by running on AVDL files, running against the Java tool, comparing that kind of stuff. And then for anything that's fixing the issues in issues slash, those agents are all going to get their own work tree where they can go hog wild on, moving things around and, changing source code and without the risk of stepping on each other's toes, and hopefully end up coming up with solutions. By the way, each agent should commit its work at the end of fixing the issue using the commit writer skill. It has a clear picture of all 16 issues. Do you now? Do you now? They both claim they have clear understandings of the problems. I find that hard to believe. I don't understand the Java class annotation in the IDL docs. I don't see a test case for it either. Does it have an effect on the JSON? I believe that what that is for is I think all properties get propagated to the JSON, but they don't have a semantic meaning. They're just additional fields in the JSON that the generator can choose to make use of. So for example, I think if you have Java class in there, for example, it'll be directly translated into the JSON as like Java class colon and then some string. And then the Rust generator will just like not care about that particular annotation or property, but the Java generator will. That's my understanding at least. So I do think it gets represented in the JSON by just getting copied over. Okay, let's see what we got. What does this one think it's going to do? We want to systematically test every AVDL file in the Avro test suite against our Rust implementation, compare the JSON output against the Java tools golden files, triage any discrepancies, file new issues under issues. This parallels the existing integration tests in test integrations. We use the CLI tool directly and produces detailed bug reports. Great. Yes. 7 agents. Why 7? Who knows? Each with a pre-assigned issue number range, so they never collide on file names and issues. I don't want these files to be numbered, but sure. They're going to run that. Check the 16 existing issues before filing. Yes, although I would like... Do I have UUID gen? Yes, I do. Okay. The tool... Okay. I have a couple of notes here. For the issues files, let's use UUID gen to give them unique names, but still include a short, also include a short description in the name. Also test the IDL. What was the other command? Schemata. No. This. Also check the mode where applicable. It should also produce the same results. Make their temp for any temporary output files that the subagents need. Use temp. Use /temp. This is so that they don't start generating those files into /temp, and then I need to grant them permission to have access to /temp. Actually, use mectemp inside /temp. Run all the agents in blocking mode so that they are able to prompt for permissions. All right, how's this guy doing? That's fine. Make me plans. Why do you need nproc? I mean, sure. I guess it's trying to figure out how many things to run in parallel. This is actually... There's an instruction I forgot to give it here. I told it to start subagents for all the issues, and I don't think that's quite right. I actually want it to think about semantic grouping of the issues and which ones are likely to touch the same files, and which should be done in what order. Analyze the issues and check for which are semantically related, and which likely require changing the same files. Also, triage them to understand which likely need to be fixed first, because they will impact many of the others. Based on this analysis, choose the order and grouping of issues to have the agents address. Have you considered trying the new agent team functionality? I saw that was released like this morning. I've not wanted to enable it here because, well, both because they're in beta and because I haven't used them myself, so I don't know how well they'll work. And also because they apparently run through token budget really quickly. And if I run out of token budget here, I just have to end the stream, which is annoying. Is it possible for these program assistant agent to actually do anything destructive? Could they rewrite Git history, for example? So, I mean, they can. In general, so there's a sort of sandbox in Claude where it will sort of analyze every command the agent wants to make. And if it's not on an allow list that I can help configure, it will prompt me, are you willing to let the agent run this command? And if you say yes, then it sort of pattern matches on that and goes, okay, in the future, I won't ask you for commands like this. It's not perfect, so the agent can still choose to come up with a command that like matches the allow list, but and therefore doesn't prompt me, but actually a different semantic meaning. Find is a good example of this, where people will often hit like, yeah, just allow the find command, but find has find-exec, which is you're an arbitrary shell. So that's probably not a great idea to blanket allow. So they certainly can do destructive things. And Git rewriting history is a good example too, although there you can usually revert it. The problem is more if you allow them access like /temp, they can just delete everything in /temp if they wanted to, subject to your performance stuff, right? Oh yeah, I never run Claude in YOLO mode or any other agent either. I'm happy for it to prompt me for permissions, and then I'll think about it. Thank you very much. I think if you run it in VMs, this is less of a problem. All right, how far has this gotten? Okay. Yep, that's fine. Great. Yeah. And UIDgen has... I forget what UIDgen is. It 7? That's like the nice short one. Is it? It's like 4 or something, but it's fine. Yeah, that's fine. Go. So that's gonna hopefully find a bunch of new issues, and then ideally we can feed those into this one later on. The plan agent produced an excellent analysis. I love how it's congratulating itself on how good of a job it did. Let me now verify some key details. That's fine. Incorporating your additional instructions. Okay, we'll see what plan it comes up with. Yes, ls is fine. You're allowed to run ls in this directory. There's also a real sandbox in Claude Code via sandbox. There is. The thing that's annoying about using the real sandbox is that you end up with then not being able to grant it permissions outside of the current directory, which sometimes you really want to do because you want to put work trees there, or you want to give it read access to some other repository you have, or like there's always like there are reasons why you might want to allow it outside, and the sandboxing can be too strict for that sometimes. It's a little bit of a I don't know. The real problem is we don't have the security granularity on the OS for this kind of thing. Something a human could do but won't might happen stochastically by LLM. Yeah, exactly. And I mean, you can figure out what sandboxing level you want, but the sandboxing level they go for has trade-offs, right? Yes, that's fine. Yes, that's fine. Yes, that's fine. This is the one where it chooses to use like bash subcommands, and then it can't like analyze them well enough to let you like go, don't ask me again. This is another example where like, oh, it wants to run Python 3 commands. I'm not going to blanket allow Python 3. That seems like a terrible idea. That seems fine. That seems fine. But that also means that I have to do this, which is annoying. Yes. 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 I'm a little sad that it decided to use Python for all of this. Prefer using Rust examples for parsing the Java code, the JavaScript, the JSON, rather than using. It's fine. Yes, 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 yes. This is annoying. Here, what I should have done is first have it write a compare JSON script that they can all use. Because instead they're all going to come up with this idea of, oh, I should probably have a JSON comparison thing, huh? Yeah, that's pretty annoying. Okay. That was a mistake on my part. All right, let's look at this fixing problems thing. Okay, so it's sort of analyzed for the different issues, which files are they likely to touch. All touch import. Yep, I buy that. Execute plan. Wave 1, independent fixes. Agent A is going to do the reference restructure. Agent B is going to do import improvements. C is going to do literal parsing. D is going to do... This is our to-do on check that these things are actually the doc comments and also add regex. E is going to fall back to namespaces. These all look like they're probably independent. They're all going to have their own branch. That seems fine. After wave 1 completes and merges into main, these agents branch from the updated main. Yeah, great. Okay. Now, where do I want these work trees to be is the other question. I actually think... So the really annoying thing here is that if I... the default is that the work trees are created one level up from where you are and then in a sibling directory. The problem is if we do, then all of the permissions have to be granted separately in that directory from where we currently are. And so I would need to re-grant all the permissions to all the agents, which is a little bit annoying. But I guess that's okay. Yeah, that's fine. Just do it. And then let me go back to saying yes to more of these Python object comparisons. That's fine. That's fine. That's fine. Oof. Luckily, these are mostly for the... like, each agent needs to do this once. But then after they're all running, they shouldn't really need to do it anymore. And they're also, these commands they want to run are pretty easy to pattern match on. This is also why people run things in YOLO mode, is so that they don't have to do exactly what I'm doing right now, which, to be fair, is pretty annoying. You can still have it fall back to the regular permission system if it can't do the thing within the sandbox. Oh, nice. Yeah, then maybe that would be a good good alternative. Oh, I really should have told it to create a single like JSON comparison tool before starting all of these. I'm real sad about it now. Yeah, that's fine. Yes, that's also fine. I don't know if you've answered this already, but how much of your time on average is spent dealing with Claude Code other than writing code yourself? It really depends on what I'm doing. Like, I don't think there's I guess on average, it like varies from week to week, because there's some weeks where I don't use agentic coding at all, and there's some where the thing I'm working on happens to align well, and so I use it a lot. So it's very hard to give you an actually representative average. I'd say if I'm in a very like agentic heavy part of my work, I could easily spend like a third of the day to half of a day like actively doing prompting. And then there will be other times when the task I give it is sufficiently like not one-shotty, but like I can kick it off and then I can be in a meeting, and every now and again it'll prompt me for something and I just hit yes and then keep going. And so it's fairly sort of self-going in the background. And so I'm doing a lot of agentic stuff in the background, but it's not foregrounded in my brain very much. But it's hard to say what the average of those are across the weeks. But again, there are some periods of time where I'm only doing things myself. I'm not really using the agents at all. And of course, there's also a lot of work that I do that is not even necessarily about writing code. It's more about like technical leadership and, setting milestones, working with teams to debug problems, like personal issues, dealing with, social planning in the context of work. Like there's all sorts of other things that come up that take up my time that are not about writing code either. I have a standard Docker container I run agents in. The source code is the only external thing mounted to it. Yeah, that's pretty common. Where I find that gets really annoying is the moment you actually want to give it access to something that's outside. I also love this. It's written a Python program for itself where it goes, actually, wait, looking at it, this means the namespace is set. But then when the schema is registered, and then let me check why. That's funny. And wait, so it's a Python. Look at this Python script. It's a bunch of code comments ending with a print of need to check. Great. Love that. I'm very glad I had to review and approve that Python file. Yes, that's fine. You can make dir that. Do you use Claude and AI for work dev or only personal open source? No, we use it at work as well, but only in there's very specific things where it's okay to use it for, and obviously we have a lot more reviews from actual other people about the code you produce. But no, we use it at work as well. For example, the other day there was there's a 1500 page PDF of a particular NATO standard for the bit patterns you use when communicating with a UAV that's flying. And the intent is to have a standard so that you can have a ground control station for the UAV that's written by country X and a drone written by country Y, and you want the two to be able to interoperate because they're all part of the same NATO deployment. Yes, that's fine. That's all well and good in theory. The problem is that the spec is 1,500 pages of PDF, where like 500 of them are like PDFs list with like reams and reams of tables of like these bits have this type with this semantic meaning. 500 pages are implementation guide on top of that. And another 500 pages are like spec requirements over the implementation. And so it's just a huge mess. This is something where it's actually very useful to be able to point a set of agents at this document and say, each agent is going to own one of the tables and implement the Rust equivalent of the struct, and then do all the testing to make sure that the bit patterns line up. And you do that for all of them. They're all parallel agents. And then you run a separate parallel set that will check all of those against the implementation guide, check all of those against the requirements and annotate them. And then you have a bunch of sort of agents checking agents, checking agents. And then you go over and check at the end. And that checking is a lot easier than writing and generating a lot of the boiler code that's just like transliterating PDF into Rust structs. But obviously for the kind of work we do, there's a lot of this that ends up being like sanity checking the stuff that comes out. You don't just want to like send the LLM off and just accept whatever comes out of it. That's a real bad idea. All right, so this is now, I'm curious whether it's finding a bunch of things. It's what? It's filed more issues, but those issues are not using UUIDs, which is what I asked it for. Oh, we're running into the fact that Serde uses B-tree maps for maps. And so therefore the keys in things like properties get reordered. This is an interesting question of like, I kind of think oh yeah, there's no accompanying test suite, or there is supposedly an XML schema that defines the valid messages, but is hosted on the web server that was taken offline 2 years ago, and there are no other copies. So, you know, fun times. The interesting bit here, I think, is, do we want to guarantee that our tool generates bit exact JSON? And I think the answer to that is no. I think there's an interesting question about whether the ordering of keys matters, but it should not. And so I think one thing we might want to add here is maybe it's as easy as like modifying the Claude MD here to say, when comparing output for equality, ignore key ordering, for example. In fact, let's add that here. Consider if we should add to Claude.md that when comparing output between the Java tool and ours, that the ordering of JSON keys should be ignored. Multiple agents independently filed issues with the same number prefixes. I told you to use UUIDs. Ugh. I actually also want to git ignore temp. It is also, so if you look at the session MD here, 21. Test files reveal multiple compounding import bugs, missing messages, qualified names, and wrong type ordering. These interact with existing issues 1 and 9 to produce heavily divergent output. Oh no, not heavily divergent. Great. Yeah, okay. Although interesting, there are some that passed. Leading underscore passed. Great. I mean, we could also set 30 JSON's preserve order, but I don't think I care about that. So preserve order there is also, it just preserve order when you parse compared to where you print. And for maps, I think it keeps insertion order. So it still wouldn't quite give us what we would be after here. Because we don't have any guaranteed about the ordering that the Java is using. So I'm actually inclined here to say that for the order, yeah, there we go. That's the actual change that I want. With the new guidance added to Claude MD, does this render some of the issues irrelevant? I'm skeptical whether these are actually doing anything because they haven't prompted me for any permissions. That makes me skeptical. Is the issue for schema JSON ordering or over the wire ordering? It should only be for schema JSON ordering because we're not doing anything about the over the wire encoding here. The order annotations, I think, you know, that's a good question. Let's go look. Sort order of a field within a record. I think that actually ends up coming out here. See the sort order section below. Note also that Avro binary encoded data can be efficiently ordered without deserializing into objects. So that's why. So I don't think it affects the serialization. But it does seem like it is an annotation that has like meaning not just in the Java implementation side. Like what is happening in the background here? Like I'm not seeing any runs of cargo, which makes me worried. Issue 17, key ordering is still a real bug. We want our output to match the Java tools key ordering. No. We're fine if our tool does not match the Java tools key ordering. It is a non-goal to match the JSON key order. Oh. I don't know if I believe that they're still working. I think they're all stuck asking for permissions is what I think is going on. Are the agents stuck waiting for permissions, maybe? It's a big problem with subtrees. The real solution to this is to start Claude in a directory where you will have the work trees rather than, so I started it directly in the directory for the main repo. If I started it like I created a parent directory and started it there, this problem would go away because the permissions would be associated with the parent directory, which transcends which descends into all of the subdirectories as well. There we go. The agents are stuck because tool permissions are being auto-denied. Okay. No. Stop. Okay. Great. This one's also done. Okay, let's tidy up the structure here a little bit. Add issues, add git ignore, add Claude, find more issues. I'm not living up to my own checkout, to my own standard when it comes to commit messages. So here's what we'll do. We will actually here we'll make dir we'll move avdl to main. We'll make dir avdl. We'll move main and avdl work trees into avdl. We'll cd into avdl. And then we will ln s main Claude here. So that way we now have the Claude permissions in here. And now I can start Claude. In fact, I can also then move main. I can move the jar into here. That's the main one. And now I can resume Claude here from the directory that holds the work trees. And now I should be try launching the agents again now. Make sure you launch them in blocking mode so they can ask for permissions. This is a known bug in Claude that the background agents are not able to ask for permissions. And it's very frustrating. Because I'm guessing if we go into any of these, oops. Stop. Right, I broke this, because this now needs to be main. There we go. And then I will set -i substitute, actually cat wtb git sed -i substitute avdl/.git with avdl main.git in wt*.git. And now if I go into any of them, ooh, what? Oh, it's real unhappy with me. Fine, I will remove the work trees and have them be recreated instead of trying to do git surgery. You'll have to recreate their work trees. Oh, this is the other problem, is that the claudemd is now different. So the claudemd here is going to say the main repository for this project is in main. Git work trees for subagents should be created in Avro IDL work trees. You'll need to recreate the git work trees. Check claude.md. Can you see how many tokens you've burned since the stream starts? I think so. Today is the 6th. So 75 million tokens, or $53. If this tool is accurate. Remember that the root of the Git repository is in main. Yeah, so this is why I was saying that I think Max makes sense for the stream, because I'm doing a lot of work here and a lot of tokens and a lot of parallel work. And so, yeah, it gets really expensive. At the same time, you know, the amount of both code we've read and generated here is pretty high compared to what I would normally do in a session. But yeah, I mean, Claude is pretty expensive, but it also does its job very, very well. All right, let's see if it... it's going to be able to... I think you would save like 8x. I think they reversed engineered the cost or something. What do you mean it would save me 8x? I'm afraid if I use LLMs too often, my brain/skills will rot away. Do you have the same concern? Or do you have some strategy to protect against that potential? So I don't think it rots away as long as you're still also doing programming and as long as you're reviewing the work that comes out of the agent. And this is where I think, you know, I draw the distinction here between vibe coding and power coding, where vibe coding is the run the agent and then don't look at what it produces. And power coding is use it as a power tool. So be really careful, don't cut yourself, and like measure twice, cut once, and review the work. And if you do that, I think that mitigates a lot, but you do have to also write code yourself. Like, it is not sufficient to just have the agents do everything. And there's also a bunch of stuff they're really bad at. And maybe you can identify that as it happens, but much of the time it's also useful just to get working knowledge with, try it with the LLM. If it does a bad job, then write it yourself. And then over time, you'll get better at estimating where should I just do it myself from the get-go. A friend reported about 30,000 euros per year per employee in the IT department for tokens alone. Yeah, I could buy that. I mean, it really depends on how well they're using it as well, right? So if you just try to use it for everything and you are not principled about how you use it, then they will end up spending a lot of tokens because they do go through a lot of churn that is unnecessary. An example here again is the you deciding to change the names and being very nitpicky, where you're causing later iterations to be more expensive because the predictions aren't going to match on the first go. And yeah, I think critical thinking skills, wrong way around, are certainly very important here to be able to get them to do a good job. That is certainly true. Why does each submodule here have to clone from upstream rather than clone from the main repo? That seems annoying. Doesn't it make you sometimes feel stupid? Like, you know, when you don't remember simple stuff that you coded used for years. I don't think so. At least I haven't had that experience. But at the same time, I also get that experience sometimes without, like, before starting to use LLMs, I guess, of like, you know, 10 years ago, I knew exactly how this function works. And I've paged it out now and that seems natural. And I don't think that's really a bug either, right? Like it feels as though if information is no longer relevant, then it should be paged out so you can fit room for other things. I don't think that's inherently a problem. And I do think that over time, as we find things that the LLMs like better to delegate the work to the LLM for certain kinds of tasks, then the relevant skills for those tasks will also fade into the background. And it's not clear to me that that's bad, as long as the things that should not be paged out because the LLMs are not good at it remain in front of your head. Since the cat is out of the bag, do you think we all have to allow ourselves, even if we don't like it, to integrate AI into our workflow to not get left behind? I mean, I hear this a lot of like this fear of, or it's like fear mongering more so than actual fear, I think, of, well, you better pick up LLMs now, otherwise the whole industry is going to move on without you. I don't think that's true. I do think that like there's like this is a useful tool. There are things that this makes more efficient. And I think not making use of that is doing yourself a disservice in a way, right? Like what happened when sort of agentic AI became particularly, this actually works for stuff. I was certainly very skeptical, and I remain skeptical for many uses of it. I basically sat down and forced myself to use it for everything for like a week and a half. And it was both in personal and work development. And the reason I did that is because it forced me to see the places it did well and the places it did poorly. If I hadn't gone through that experience, I wouldn't even have known when the tool was appropriate and inappropriate to use. And I do think it's very worthwhile to go through that experience of like forcing yourself to do the due diligence here of at least learning what the tool is and how it works. I do also think that when you go through that exercise, you come out the other end with a new tool in your tool belt that you can wield hopefully responsibly and know what to use for. And it will make you faster for some tasks. And there's also a good point here that like some of the ways in which it makes us think is very useful, because I think as programmers, when we write code, we sometimes get lost in the details. Sometimes that's necessary, but other times it means we sort of lose the forest for the trees. And so it can be really helpful sometimes to work through an agent where you have to actually describe the problem you're trying to solve and the end state you're trying to get to, rather than being too absorbed into the code to see that you're actually building the wrong thing. And so it forces you to take a step back. Again, applies more so in some cases than others, but even so. Better pick up LLMs now, but also the model 3 months ago is outdated and you must learn again. I don't think that the learning changes that much. I just don't think they're all that different. Like, sure, they've gotten better at keeping more context and what commands they can execute and integrations and all of that, but it's not like it's hugely changed how I interface with them now versus a few months ago. There was a really interesting thread by what's her name? Leah Veru. She's like a big name in the sort of web standards space, where she basically sort of equated the increased use of LLMs to the invention of like the C programming language, where people suddenly stopped writing assembly and started writing like higher level code that was not assembly. And then the same kind of critiques came up of like, well, but obviously, what's happening here? Obviously we can't let some program just turn this into assembly for us. It's going to generate terrible assembly. And I don't think the argument quite holds, just because I do think there's something meaningfully different between a deterministic program that turns like syntax into into assembly and something that is much more stochastic, like an LLM is. But the analogy is kind of apt, right? That why are we saying you have to write the code? Again, there are some things where you do, but it's not clear to me that in every case it's bad to have a sort of higher level abstraction to the writing of the code. It really depends. Decomposing and formulating problems as tiny bite-sized chunks is a skill that I've developed during my career, and it feels like I haven't exercised it to the same extent with the emergence of LLMs. I actually think I use it quite a lot with LLMs too, because I have to help it decompose the problem. I think that's actually one of the things that LLMs are not that good at, or rather they might come up with a decomposition that I think is the wrong decomposition. Like it will lead it down a bunch of incorrect paths. And sometimes it's useful for me to decompose the problem for it and say, no, do these things in this order first, and then you go and actually do the execution. What do you do in between waiting for agents to do in work? Oh, I have enough things to do that I don't struggle to find other things to fill my time. It also means that I can work on more things sort of in parallel. The trickiest part actually is keeping enough context and working memory that I can switch between them, because the agents obviously can, because they just have more RAM in each case, right? But me being able to meaningfully review and reply to them, that becomes the bottleneck eventually. But there's enough stuff of like interacting with peers, making sure we build the right thing, talking to customers, talking to partners, like doing research, like learning for myself, all of those things that in a way I get to spend more time on now. Are you using any MCP servers like RustDocs or memory MCPs for it to gather and store knowledge? I haven't really been using MCP so far. I have the LSP MCP enabled. And I also have I have an MCP I wrote for working with large PDFs. This was for that NATO standard stuff. But those are the only two MCPs I've used so far. I do know that people like them for things like persisting knowledge so they can fetch it back later, or for accessing RustDocs, although there I think the LSP integration is actually pretty decent. But no, I wouldn't say I'm like heavily making use of MCPs. The flicker gives me ADHD. I know the flicker is real bad. It's a known problem. One of the fixes actually is to zoom out the terminal. But if I zoom out the terminal as much as I normally would, it would make it impossible for you to see it. Maybe not. Let's see. Like if I zoom out, it's like this much-ish, then the flickering goes away, but it's also harder to read. Have you had any problems trying to diagnose an error running service when no humans on the team have mental ownership of the details of the code or implementation? Not quite in that regard, but I have ended up using LLMs for, so there's a C library called NNG, which is like a network protocol implementation thing. And I had written Rust bindings on top of that. And then I'd written so that was like a sys crate to NNG. And then I'd written an asynchronous wrapper around that crate to be able to use it from like Tokyo. And then I'd written a Rust program on top of that wrapper around the sys crate and around NNG. And I had the context for all the Rust parts of that still pretty fresh in mind, but hadn't spent much time in the NNG codebase itself. And obviously there's an NNG maintainer I could like talk to, but they have their own shit to deal with. I don't want to disturb maintainers if I can avoid it. So I didn't have any context on the C codebase. But what actually worked really well was telling the LLM, here's the levels of the stack. Here are the pointers to the code for each of them. There's this bug in the top level code. Create MVPs that reproduce the bug at every layer of the stack and keep going until you cannot reproduce it anymore. Like basically find me which layer in the stack the bug is in and give me the MVP for that layer. the minimal viable, it's not MVP really, it's like the minimal reproducible example. And did that great. It ended up with like a C reproducible example that found an actual bug in NNG. And that helped enormously because it meant I didn't have to build the context on NNG itself. So that was very, very useful. And it was certainly something where I didn't have mental ownership at all over that code base. And yet the LLM was able to give me the insight that I needed for it. My glasses need glasses for this font size, I know. Yeah, I mean, it's just to avoid the flickering, although I think now now we can zoom back in here. Yeah, let's do the merges. Bring him back into main. If you had a chance to try out spec-driven development, I mean, arguably all LLMs are kind of like that, right? Like if you work diligently on the plan, then the plan sort of becomes a spec for them to write after, but not in the more formal sense, no. Yeah, so well, what's interesting now is you'll see what it's been doing is each of these separate agents are now finished doing their fixes. And now it's going through merging each of those fixes into main. And then for each one, it's running the test suite and it's seeing, oh, we're still getting the same test failures we got before. So nothing is regressed and that's fine. So it's not being naive and going, oh, it failed, now I must stop, but instead realizing that it's the same test failure and just moving on, which is what we would have wanted to do. And so the hope now is that, it's going to do this wave of the first iteration of fixes, and then it will go into the second iteration of fixes by, again, reusing the work trees. And from here on, I would expect it to basically be able to continue to drive its own development, right? Of alternating between finding more issues and then fixing them, finding more issues and then fixing them. So the plan I would end up constructing for it here is a plan that specifically outlines that strategy of I want you to alternate between these two phases. Like don't run one and then the other and then finish, but run the first, which is identify the issues, then run the categorization and sort of ordering, and then run the agents to fix them, and then do the merging, and then go back to doing the issue finding. And that way, once you give it that loop, it can execute that loop relatively independently. And so that's what I want us to get to next. For the persistent question, is there a reason as to why you're using an LLM to code for the stream? Is this stream meant to be about LLMs for development? No, I've answered this a couple of times over the course of the stream. There's also a mention in the description of the video for why specifically we're using LLMs here. And the short of it is that this is a use case where I think LLMs actually can do this job really, really well and really quickly, where like it's used the right tool for the job. That doesn't mean that I use LLMs for everything. How do newer engineers differentiate from LLMs? I think one big difference is that more junior engineers learn, and the LLMs don't really learn. You can kind of emulate it, right? So you document each of the things that you see them making mistakes of, and then in the future, they make fewer of those mistakes. But one of the big differences is that the LLM it doesn't understand the guidance that you give. It doesn't understand the problem it really made. It just, it can sort of emulate that understanding. But I've found that with junior engineers, I feel like I can make them better over time. And the LLM, I can't make better. Or I can steer it so that it makes fewer of the dumb mistakes, but it doesn't actually grow into a senior engineer that has better judgment. And that I think is the biggest difference. Is there a huge difference between XML and JSON? I've never worked with them. That is a weird question. So yes and no. They have very different syntax and very different standards. JSON is a lot simpler than XML, both in terms of parsing and in terms of what you can represent. XML is more used in enterprise, is a little more used in older systems than newer ones. JSON is a very simple file format that was sort of inspired by and primarily driven by JavaScript. Yeah, I keep merging. I want to get to the point where we write the plan so it's self-going. Yes. It is interesting, though, that it's still failing on the same 2 tests. Oh, Clippy's going to be unhappy about this code base is my guess. There's another language for sort of textual representation of data that I really like called Cuddle, KDL. And Cuddle is a fun one where it's sort of inspired by TOML, but TOML is really bad at recursion. Cuddle is written to recurse a lot better. But it's like, it's unclear that you would use Cuddle in place of JSON, but you would use it in place of TOML. So it's like we've seen this divergence now in things that are used for data and things that are used for configs. And like maybe they should actually have different languages, which is going back to what we used to have with INI files, which are config only format. You would never encode data in INI. I am really curious how it ends up fixing the error source location stuff, because in a way that's obviously the main thing we wanted here was the ability, or the main improvement over the Java one, apart from not being Java, is having it give much better errors when either there's a parse error or when there are semantic errors on top of the code. Have you ever joined a Rust codebase with an architecture you disagreed with? How did you influence change as the new person? Well, so I have been brought in to basically do code review for code bases that aren't mine. And when doing that, there are certainly things where I go, well, this doesn't make a whole lot of sense to me. Sometimes that's because I don't have enough context. Like, it's actually a reasonable design. It's just that it's not obvious from the outside that that is the case. You kind of need to get into the specific semantics and use cases of what it's built for to realize that it makes sense, or the constraints that they have when building it. I'd say I don't feel like I've usually run into cases of I think it's completely wrong and the team that built it think I am completely wrong for thinking that it's wrong. Like, usually you sort of enter some amount of alignment. But this also depends on how you approach conversations with other people, right? If you approach them as, you've done this wrong, they're going to enter a defensive posture immediately, right? Whereas really what should happen is can you help me understand why it's done this way? And then they explain, and hopefully you can go, oh, but doesn't that mean that? Or, have you run into problems with? And then you can sort of guide the conversation so that you understand the requirements and conditions they have, and they understand the insights or experience you might have to bring. And you come up with actually these things should stay the same and these things should change. Yeah, empathy. It's a weird word, huh? Did you have the agents convert all of these issues into regression tests? No. And part of the reason is because for some of these, they're just like, the thing doesn't work. But for many of them, it's this AVDL file that we get out of the Avro repo doesn't convert or doesn't convert correctly. And those will already be our test suite. Our test suite is already running all the AVDL files. So those are already regression tests that we will continue to have. Have you figured out a good agentic workflow for formatting Clippy? No, I have not. It's very annoying because the LLMs tend to generate code that's not quite formatted and not quite Clippy clean. Format is the worst one. Clippy is not so bad. But for format, the moment it formats the code, or I format the code for it, then it needs to read the whole source file again, because the source file caching claims that the file is no longer up to date, which makes sense because if it now tries to edit the file, all the line numbers will be wrong, so its diffs will be wrong. So like, it's correct that it needs to read the file again, but I don't want to spend context on keeping two copies of the same file, one which is formatted and one which is not. So what I tend to do is just not do formatting as part of any part of the LLM interaction. And then when all of the LLM stuff is done, then I'll do a cargo format and commit. So I usually try to not do any of that in the LLM sort of critical loop, if you will. It's very similar actually to the forcibly apply my style to the LLM while it's iterating, of saying, no, rename this function to that, where I try to avoid doing that for the same reason, because it confuses the LLM they're in two different ways, right? The formatting confuses the LLM in that the file looks different. The renaming confuses it in that its future predictions will be wrong. But in either case, kind of just like let it cook is sort of the expression, right? And then after it's done, then you can say, okay, now I'm going to run cargo format and I'm going to commit that. Or then you stop the session, you say, start a new session, please fix all the Clippy lints, end that session, start a new, and then just run cargo format and then commit the result. Does one need to learn the lingo? What does Claude doing spelunking mean? No, this, the blinking thing in red here is usually filled with a placeholder that's just a synonym of the word thinking. And this is like it's entirely a humorous thing from Claude, or from the Claude team, right? Of like, we need to show that it's doing stuff. And we don't want to just say like thinking. We want it to be a more fun experience than that. So we're just going to pick a random new word each time, spelunking being one of them. And then what they've recently changed over to is sometimes it will basically use another LLM to summarize its own work and put that summary of its work into the prompt or into the status bar here instead. Seeing using LLMs more, no more Luddite. It's like yes and no, because I'm I still don't think LLMs understand. And this is sort of and I don't think they're on the path to understanding either. I think I have it like, this is the sort of controversial statement from me, is that I don't think I've seen LLMs get better over the course of the past, let's say year, in the axis of understanding. They've gotten better in other ways, like being able to use tools, having more context, being able to recognize and repeat more complex patterns and combine them. But in terms of the understand what's happening, not really. And that I think is also why there are a bunch of use cases I don't find them useful for, because they're not able to solve that kind of problem. And so I remain a Luddite in the sense that I don't think this is coming to replace all of the work that we're doing. I don't think every task is amenable to being solved by an LLM now or in the near future. But I also definitely agree that having used them more now, there are some use cases that they are very good at or very efficient at. And for those, it feels like it's a very worthwhile tool to learn, know, and use. As AI takes over most of the coding tasks, I don't agree with most, but some. What skills become more important? How would you suggest improving on them? I think the skills that I think actually are already important, but it becomes even more visible that they are important, is critical thinking, like the ability to take especially the plans, but also the solutions that come out of Claude, and thinking through, is this actually a good idea? Is this how the decomposition of is this the correct decomposition of the problem? Is it the correct identification of the root cause? Is this where the solution should be implemented? This is how this solution should be implemented. I think the second is actually like ability to review. I think a lot of programmers are actually pretty bad at doing code review, whether it's from LLMs or from other people. And that skill is even more important now because there is a lot more to review because you're also reviewing incrementally as it goes. At least I think that's the sane way to approach doing so. So like that skill of getting good at reviews and being good at giving actionable feedback in reviews becomes very critical. And I think maybe a third is just like reading and understanding speed of code. So traditionally, because you wrote all the code yourself, you were understanding it as you were writing it. So your understanding speed only had to be at the speed at which you can write the code, because you usually will like understand it and write it concurrently. Now there'll be a bunch of code that gets presented to you that you didn't write, and now you need to reason about it. And so the speed at which you can read and review that code starts to become a bottleneck for the workflows that are particularly LLM prone. And so I do think that is an example of like skills that they're all three very useful from before, but they become even more critical now. Adding correct context is also one of the things that it's really important. Yeah, that's true. And I think this is another thing engineers are pretty bad at is recognizing that the person you talk to don't have the same context you do. So you try to explain based on the context you already have, and the other person doesn't understand because you haven't conveyed that context to them. And LLMs struggle with the same thing. If you try to give them a problem, but you don't give them the context that's in your head, they have no hope of being able to solve the problem well. And so it forces us to get better at that kind of context transference. But again, I think this is a skill that good programmers and engineers have anyway. And so it translates very directly. But working with LLMs makes it even more obvious if that is a skill that you still need to develop further. Okay, I'm hoping this is nearing done with its background task, because for once I actually have a hard stop to the stream. So I have a thing at 3, which is in 40 minutes. So the stream will end in 40 minutes minus epsilon. And so I'm hoping we get to do one more iteration of setting up this sort of critical loop for the development, so that I can basically, my hope, right, is that I can kick that off, see it go through one loop, and then end the stream, and then just leave it running while I go do my things that happen separately. I've been learning to read code faster from your videos, especially those of the decrusted series like the Axiom Crate. Those videos are real assets. I'm glad to hear. I do actually think that like reading speed for code is like is a superpower in a way. It is actually really, really useful to be able to just like scan code quickly and know roughly what it does and sort of spot the patterns and spot the implications of the code pretty quickly. I was trying to solve the error source locations. I'm so interested to see what that looks like. Which one is doing that? This one. I just want to see how it produces these diagnostics. Yeah, see now, so now it has a make diagnostic helper where you pointed out the source and the property. The star token uses a byte offset in the original source text. Yeah, so it creates spans. Okay, great. Now we're getting, that's going to give us much better errors. I'm very curious to see how those turn out. I also, this is actually another thing that I would like it to make more use of is, see all these like question marks where it just bubbles up errors. I wanted to start using .context to propagate information, not just about the lowest level parsing error, but what was it doing while doing that. So let's go ahead and go back here. Move main. Actually, we'll do it here. For every consider whether we should be propagating additional context. I think Miette has context, right? Or does it not? No, it's too big. Yeah. Consider whether we should be propagating additional context that would be useful for users when the error eventually bubbles up to them. For example, if A imports B and B has a syntax error, it's valuable for the error to point to A's import of B. I've used LLMs in a more interactive way, like letting it work on a much smaller scope and being able more in control about each line of code it generates. Yeah, if you look at the first stream I did with LLMs, where we try to implement like a pretty non-trivial change to the Squaba library, like it's a spatial reasoning or it's a library that deals with sort of coordinate systems and coordinate system transforms and rigid body transforms. That one was much more like that, where I was reviewing each thing it did because the code was fairly intricate. So that, yes, you could take a look for that one. All right, let's finish with the agents. All 16 tests pass. Great. Agent J, this sounds like Men in Black. Not a bug. Grammar limitation. Record body rule only allows field declaration, not named schema declaration. Documented the finding, removed unused registry parameter for walk record. Cool. Added source info. Now merging. Yes. Do you let your agents use the internet, especially at work with sensitive information? I saw a CVE where malicious documentation could trick an agent to expose a secret in a seemingly innocuous curl. So I do let them use the internet in limited capacities. It really depends on what I'm trying to do. At work, this is less of a problem because we have a bunch of sandboxing around the agents as well. So there's not a whole lot that can go into them. And the control over what they're allowed to access externally is also controlled. So less of a problem there. But for the work that I do personally, it sort of depends. Like, I will let it go to documentation for things, for example, if I think it is worthwhile. And this one's tricky, right? Like, if the owners of like DocsRS decided to inject like bad prompt injections into the source code for DocsRS, that would be a problem. Like, that would make me sad. And I don't have a great solution for that. And then the closest is probably to do things like grab it with like browser automation instead, and then using like extraction, like use the browser to extract only the visible text. Like, this is the path we would end up going down, which would make me very sad. Do we actually, this is an interesting question as well. In main, do we, in source, Yeah, that's what I thought. Oh no, we do. Great. So we already have a test that grabs the AVDL files from inside of Avro. So that'd be Avro slash. Yeah, great. So that actually means that if the tests now all pass, it actually means that we now are able to parse all the AVDL files and produce the same result as what Avro itself would have done. Neat. And I mean, we could test it, right? So let's do cargo run. Actually, let's do the Java one first. Let's do the IDL. And I want this to be, let's do another, the namespaces. Let's do baseball to baseball.avsc. Oh, right. And then we do cargo R, IDL, and then I want baseball 2.avsc. And if I do JQ to baseball AVSC, and then I diff these, what do I get? Yeah, so the fields are in different orders. That's fine. Fields are in different orders. Fields are in different orders. Yeah, so it actually produces the same resulting JSON. Okay, so that's not bad. So we now pass all of the same tests that the Java code has. And this is what I mean. Okay, we've been doing this now for, what, 4.5 hours. What we have now is a relatively complete parser that passes the same input tests. Obviously, there's more tests that needs to be done here, right? Because just because it works on the particular test cases they have does not mean that it works for arbitrary AVDL files. But it is a pretty damn good start. So now, here's what I want to do. That's fine. Actually, let's leave the work trees for later reuse. Document that in, yeah. Oh, JQ-S. Did not know about JQ-S to sort the keys. All right, and now let's see if we can go one step further. Do we still have the issues directory? Okay, great. Triage the issues directory. Triage issues for which of them can now be removed as they are fixed. Just have it also do that. The other thing that I want out of this is you'll see there are a bunch of Clippy warnings. What if I run Clippy? What do I get? Okay, let's then do, hey Claude. Yes, that's fine. Address all the Clippy lints. Just have it do that in the background. And then streams AVDL. The next thing I want now is as follows. And this is where we're going to get into a bit of a combining prompts game. So remember, we have this prompt. Which is the one we set for starting testing. We have this prompt, which was a continuation of that prompt. We have, oops, no. We have this, which was a continuation of that prompt. And then where's our, we have this 4.md. Because what I'm aiming to do here is build a I want to build the sort of self-fix and find problems loop. But what's missing is yeah, I think we now have all of those prompts, and now we gotta put them together. Great. Adjust the files in issues accordingly. Did it not? Yeah, it did not do that. And so now what I want to do is combine these prompts. So cat prompt star .md into prompt.md. And now we're going to try to see if we can make this be a single loop. So we're aiming to create a self-correcting loop of development. To set up a self-correcting loop of development, do the following phases in order. Then, when the last phase is completed, return to the first phase again. Only exit this loop when the first phase finds no new issues. Phase 1 is going to be this one. Start many subagents, each of which should run, start many subagents in main. Each of which should run the current implementation of the IDL tool on the known Avro IDL files and compare the output to the expected output running the Java tool. If discrepancies are found, the agent should do a first level triage of the observed bug and then file an issue under issues. File name should be UUID gen plus short description. The agents should not attempt to fix the issues and should prefer to debug issues using Rust example files and examples that are run with cargo run-examples. They should avoid changing the source files in source as much as possible to avoid stepping on each other's toes. Run all the agents in blocking mode so that they can request permissions if needed. If agents need to compare JSON outputs, use jq-s dot to get sorted keys. To get sorted, formatted JSON that can then be compared for equality. Phase 2. Well, then I guess commit all the new issues. new entries and issues using the commit writer skill. Phase 2, for each issue identified in issues, this is where we want this thing to be first. So we changed that last time. Analyze issues and check which are semantically related and which likely require changing the same files. Also triage them to understand which likely need to be fixed first because it will impact many others. Based on this analysis, come up with the order and grouping of issues to have sub-agents address. For each such grouping, run a sub-agent in one of the workspaces. Work trees in AVDL work trees. In one of the pre-existing work trees. Check out a new branch that branches from main. Pre-existing work trees, check out a new branch that branches from main. Run a sub-agent to debug and fix that issue. And again, run those agents all in blocking mode so they can request permissions. And again, to debug issues, use Rust example files that are in the cargo run example. Each agent should commit its work at the end of fixing the issue using the commit writer skill. You should then merge all the fixes back into main after each wave of agents has finished. Is there a phase 3? Phase 3 is maybe cargo format and cargo clippy. Phase 3, fix all cargo clippy warnings and commit. Run cargo format and commit. And then go to phase 1. If there are no new entries, do not go to phase 2. Now this will be interesting to see. Oh, what is this? Expand macros of the error module to understand the warning source. No, ignore that warning. And this is still doing stuff. So this is the prompt we're going to try to give Claude and see if it's able to sort of create that self-reinforcement loop. I do want to change phase 1 a little bit more. Start menus, each of which should attempt to identify issues with the IDL, or I keep forgetting the name of the other tool. IDL2 schemata. And IDL2 schemata subcommands. They can do so by investigating the tests in, and this is where I want to look at what's in main Avro. Like, I wonder if there are other things in here. Yeah. Because there's also Java tests in there. That's what I wanted to check. You can do so by investigating the tests that exist for the Java implementation in Avro/this, including running on known AVDL files, the Java unit tests, etc. And compare. Great. This finished, so that can go. This finished. What is Cargo Clippy unhappy about? Ah, that's fine. I don't care about these. I actually don't think I wanted to try to fix all Clippy. But cargo format, I don't want it to cargo format either. Phase 3, go to phase 1. Because this will still happen in the same context, and so I don't want it to pollute its context using by being forced to reread the same source files. So I will actually leave that as is. That's fine. Yeah, why is it wanting to change the status of all these? Mark issues, update issue status. And then this is fix Clippy warnings. How do you navigate in Tmux quite quickly? Is it the default set of shortcuts? Mostly. So I have my prefix set to Control A instead of Control B, so it's closer. And then it's just, and then I can use Control B to go back by page and Control D to go down by page. I don't understand why it's wanting to check the diff for all these files. Just stop, stop, stop. Okay. So now let's see how this prompt fares. So we're gonna rm0 rm prompt 1234.md, but not our main prompt. And then here's what we'll do. Start Claude. And then we will paste this. And then I will say, by the way, also a first issue to introduce in is the one outlined in todos.md. And then we shall see if it comes up with a plan that can self-iterate. Are we initiating the singularity? Maybe, but I don't think so. Is that the default Claude banner? Mine takes up more space and shows my email. I don't think I have any particular settings there that would make it smaller than usual. I don't understand how multiple agents are working simultaneously. Are there issues with syncing? Yeah, that's what the work trees are for. And then the interesting thing bit now will be, what kind of plan does it turn our prompt here into? I think it should come up with something fairly reasonable. Like, this is arguably already a plan. But it is useful to have it turn it into a more formal plan, because that gives usually a little bit more detail, and that getting that detail right can be really important to get the loop to actually start spinning. Oh, yeah. Don't forget to tell them to have mercy on you. There's actually, there's a really cool brutal review. So this thing, I'll put it in chat as well. This person wrote a prompt to make any agent really give you a really critical code review for the latest Git commit. And it's actually really useful. It tends to come up with pretty good insights. It's always a little bit too much, but it's a really good starting point. And And so I don't want to tell the LLM to use that when it makes changes, because it tends to be, that review skill tends to be overly pedantic, and I don't want it to be stuck on the pedantics. But it can be really useful for when you write code and you want someone else to check it before you actually submit a PR to your own project. The other thing we should probably add here is should just start with to the initial plan. How can we improve the Rust test suite for the crate to have a more robust test suite natively? I should arguably tell it to check todos.md on each iteration of the loop so that I could keep adding things to it. But given that the stream is about to end, I will probably not do that. I just want to see it sort of get to the first start of the iteration. All right, let's see. Okay, context. Ports the Avro IDL and scanner. Well, several inputs are untested. There are 4 known issues, and the to-dos MD identifies a missing error context propagation concern. The goal, oh, you can't see this behind here. The goal is a self-correcting loop. Find issues, fix them, verify, repeat until clean. Launch 6 sub-agents in parallel, all blocking, all in main. Each agent investigates a specific area by running the Rust tool via cargo run-example and comparing against Java golden files using JQ-S. Agents file issues under issues, but do not fix the source code. So one problem I can already see is that for phase 1, it is outlining what the current issues are, but the intent is that it should over time find new issues. Read all issues, triage by dependency order, group issues, work on the same files, assign to a work tree, merge, and return. Okay, so on subsequent iterations, we'll need agents to identify new issues rather than just recheck the same ones you've listed in the plan. You can think of the current phase 1 issues as a seed for the first iteration, but on subsequent iterations, phase 1 becomes a more open-ended discovery exploration phase for finding new ones. No matter if this works, I still think the fact that we can think of it to work in a few hours is fascinating, right? And this is what I mean by this feels like the kind of thing where, and I think this is turning out to be true, a thing where the LLM is really good at this kind of task because a lot of it is transliteration of code from one language to another. And we have a good reference. We have a spec. We have a large number of test suites where you can test files where you can actually check another tool for exactly what the output should be. And so it has this ability to drive itself. And so even though, would it be faster than if I wrote this code myself? I genuinely think so. I also think it's fine if the code is slightly suboptimal compared to what I would have written, because it also meant that I got to spend 5 hours to build this tool rather than spending a week to build this tool. And that difference matters if the end result is they both produce the right output. First iteration, subsequent iterations. On each re-entry to phase 1 after the phase has been merged, the initiative to open ended exploration rather than rechecking the same areas. Strategies include... yeah, fuss stress test with handcrafted AVDL files. Great. Clear context. Auto accept edits. Run. And then now we'll see it run. Hopefully, yeah, it's a very well-defined problem and one that has a very good. It has a very like on rails iteration loop. Like you kind of know what to do each time. You know where you went wrong, and that it gets really good at. Oh, I forgot one thing in the plan, which is that did I write that they should commit? Yes. Okay, I did. Good. All right. I just want to see it. This is one that I'm like, I don't know whether I want to allow cargo run, because cargo run means it could, in theory, build a program that does something bad and then just run it, and I've given approval for it. So I tend to not allow cargo run, but the same problem exists for cargo test as well, right? You can put arbitrary code in the tests. All right, fine. We'll just allow cargo run. I'm looking at what plans like Claude Code Max cost currently and what the corresponding tokens over the time of a month cost in the real world. I'm still questioning the future feasibility. I know. I think this one of the big questions here is whether we'll get inference to get significantly cheaper, ideally local. And I don't know yet. Like this feels like it feels like it should be doable, but I couldn't tell you. And it's also true that, as someone pointed out in the chat, like there are a lot of problems that are not as well defined as this one. And in those, LLMs can maybe help with part of the task, but not the whole task. Or they can help you iterate on the task, like by doing reviews or helping you generate tests. But again, you can't just trust their tests to be sufficient on their own. And so use them in an intelligent way. Use them as you would a power tool. Don't use them as I'm only using this thing from now on. It does not work that way. Yeah, let's check what CC usage ended up at. Okay, so today, $73. So actually, Max was not worth it. According to this measure, Max was not worth it. Because I've used less than the Max thing. It will be worth it if I use LLMs more over the course of the coming month, which I probably will be. So, but like for this session alone, Max is not worth it. Let's see. What is it? Why did it decide to run them in non-blocking mode when I told it to run them in blocking mode? Agents just stuck waiting on permissions. I told you to run them in blocking mode. Make sure that's reflected in the plan going forward. Why? Why? I was very explicit. Oh, but maybe it didn't make it into the plan. Well, I think the I've at least conveyed the idea, right, of the next step now that we have a command that we've seen actually produces the same JSON for at least some of the AVDL files, is now to just keep letting that loop iterate, and then reviewing what comes out of it, making sure it iterates again, and then gathering more and more of those input test files. And given we're now at 4 minutes to my next meeting, I have to actually stop the stream. But what I'll do is I'll push this to GitHub. I'll upload the video to YouTube as always. And then, if you're watching this after the fact, you should be able to now go to see the GitHub page and see what changes have happened since this last commit. Last commit is rev parse head. That commit. So you should be able to see what has changed since the stream and where the agents got to, and what commits have been contributed. And hopefully it'll actually be a useful tool by the time you go look at it. Cool. Thank you, everyone. I hope that was interesting. I hope it was fun. I promise not all my streams will be prompting LLMs. We will also do like writing code ourselves. It's just that this was a good example of somewhere where LLMs are actually really useful. And then there are others where they are not. And we will see some of those too. Thanks for coming out. Thanks for watching, and I'll see you next time. And of course, to those of you who watched live, it makes a huge difference to have you here. Thank you so much. It's way more fun when I actually get to talk to you over chat and hear your questions and try to answer them. So thank you all.